Hello everyone, today in this video we'll be discussing the previous year questions, model questions and the important questions of automata. And in this video it's like a reference video, okay? So if you're solving any questions and you have some doubt in that how I got that answer, so you can come back to this video at that particular time stamp and then look at that solution, okay, and explanation. So this is just for the reference video. I'll make another video regarding what you need to study, like what are the important questions. These are just like all the repeated questions and all those things are there, okay? So I'll be making a separate video on that, and let's get started with this. And if you like this video, hit the like button and don't forget to subscribe to my channel. Okay, so these are the topics which we have in each module. So if I give you a brief overview, like a fifth module is like full theory, okay? You can easily learn this one and write the answers. So basically from these topics only the problems are asked, okay? And coming to module 4, we have two parts here. The first part is the Turing machine. If you know the way of solving the question, you can easily solve that one. And the next is the theory questions. Just like this one, we have some theorems which you need to prove, okay? So make sure that you learn module 4 and 5. It's very easy. You can score like 40 marks, okay? And after that, the next one, I'll be telling you what all topics you need to choose from each of these modules so that you can get marks easily, okay? So let's get started with the first module. Like first you need to know the definitions, and then the how to draw the DFSM and non-deterministic finite state automata to deterministic finite state automata. For that the conversion is there, and after that the minimization is there of FSM, and finally we have finite state transducers, okay? So let's get started with the basic definitions, and I request you to open the same PDF in a different device, so that I'll be going through the answers and you can look at the questions in a different device, okay? So the first question is these are the important definitions which I have repeated many times. So let's see what are these definitions, okay? The first definition is alphabet, okay? So what is an alphabet? It's just a set of symbols like ABCD which we use in the transitions in automata, right? That is known as alphabet, okay? And power of an alphabet means, suppose that there are two alphabets here, 0 and 1, okay? So in that case, how many sets are possible? Sets means what are the possible strings. If I have a set of length 1, I can just have 0 or 1. If I have a set of power 2, at that time I can have 0 0, 0 1, 1 0 and 1 1, okay? So that is known as the power set of an alphabet, okay? And the next one is concatenation. In concatenation, we have, like, if you have two strings like L and M, and here the strings are 0 1 and 1 0. If you concatenate them like L dot M, so that it will become 0 1 1 0, okay? That is concatenation. Then we have language. Language is what? It is a combination of the letters to form a string, okay? That is known as language. And string is just what will be formed in the language, that is the combination of the alphabets here, like CAB, CAD, okay? That's a string. So these were the repeated definitions asked in the previous year papers. Now let's start with the deterministic finite state machine, okay? So the question will be like define DFSM. So the definition you can look at in your book, and let's get started with the how to draw that DFSM, okay? So in the DFSM, the first question is accept at least one A, okay? So what does it mean, accept at least one A? What are the possible strings I can have? If it accepts only at least one A will be there. Another possibility is AA, or if B's are involved, it will be AB or AAB, like that. At least one A should be there. That's my only condition, okay? And so how can I design a machine for it? Whenever you are given to design a machine, what you have to do is you have to design the machine for the least string. What is the least string here? Just a single letter A. So how you will design is, here you will have Q naught, okay? This is the starting state. You have to make like this starting state. Then you have to design the machine for the single letter. This is the least string. So for the least string, I'll have A here, and I'll reach the final state, okay? That's all what you have to make in the initial stage, okay? Like this is the minimum string, and you're reaching the final state. Now how many letters you have, that you have to keep in mind. You have two letters A and B. Now for each of these states, you have to define what will happen if the transition is for A as well as for B, okay? So for this, A is already defined. What about B? About B, I have no transition as of now. So what can I do? See, what is my condition? It should accept at least one A. So without accepting without accepting an A, I cannot reach the final state. So if it is a B, initially I should remain in the same state until and unless I get A, I'll not reach to the final state. So I'll have a B here. Okay, now A and B is done for this one. Next I have to consider A and B for this one. Now for this A and B is not defined. Now what is my condition? At least one A should be there. I have reached this state means I have got at least one A. Then after that any number of A's and B's I can have, I'll have in the same loop, A comma B. Okay, so this is what I have drawn here, B self loop. At least one A should be there, I'll reach the final state, then n number of A's and B's. Okay, that's how you means design the machine. Okay, the next one is exactly one A. Exactly one A means only one A will be there in all the strings, and there can be any number of B's means before it or after it. Okay, that's my condition. So at exactly one A means what is the least string? It is A. How can I how can I draw the machine for it? This is the starting state Q0 and this is the final state. I'll have just one A, exactly one A. Now I have to do for B's also. I have to define the machine for A and B for each of these state. For this A is done. What about B? I cannot reach the final state unless I get one A. So B will be remaining in the same state. Then when I reach here, I can have n number of I cannot have n number of A's, but I can have n number of B's, because exactly one A should be there. Suppose that I get another A, it should go to the trap state. This is known as trap state. Then after that, if you reach the trap state, if you get n number of A's and B's, that will remain in the trap state. Okay. Coming to the third question, at least 2B. At least 2B means you tell me what is the least string, BB. After that, you can add any number of A's in between and before it or after it. Okay. So for designing the least string, I'll have B's and B's here. After that, I can have n number of A's in the starting or in the middle or in the end. So A here, if I get A, I cannot reach this state because I need at least 2 B's, so I cannot move forward. When I get a B, I'll move to the next state. Here also, if I get a B, I'll move to the final state, else I'll remain in the same state with the transition on A. Okay, and after that, when I reach the final state, my condition is over, like B's and B's are already taken. Then I can have n number of A's and B's. Okay. The fourth question is even number of A. Okay, even number of A means it can be either epsilon, 0 A's because 0 is an even number, or 2 A's or 4 A, and in between I can have B's also. Okay, any number of B's. So I should have even number. So how can I make sure that I have even number? If the starting state is only the final state, in the epsilon transition I can go to the final state directly. So epsilon will also be accepted. Suppose that I want 2 A's. So I'll go to this state here. If another A I encounter, I'll come to the final state. If I don't encounter A, I'll remain in the same state. Okay, because I cannot accept odd number of A. Single A, it should not be accepted, so it will not reach the final state with single A. Okay, and B's will be having a self loop here, and that's all about the fourth question. The fifth one is odd number of A's. In odd number of A's, what are the least string? 1A, 3A, and n number of B's in between. So at least 1A should be there. So this is the starting state. On 1A, I'll reach the final state. Then I can have n number of A's, like if I want 3 A's, I'll come back to this state again, another A. So 1 plus 2, again if I the next odd number is plus 2, again here like this. Okay, and in between, in any of the state when I reach, I can have n number of B's. So I'll have self loop for B here. Okay, that is about the odd number of A's. The next one is at most 3 A's. At most 3 A's means at max I can get 3 A's. Okay, no more than that. So what are my possible strings? Epsilon, because epsilon is 0 A's. I can get a single A, I can get double A, and I can get triple A. And in between I can have B's also. Okay, so my least string is epsilon. So whenever my least string is epsilon, that means my starting state is the final state. That I will make for means in the initial state I will make this one. Then I can get 1A for 2 A's and 3 A's. I have to design. Okay, for that 1A, that's also the final state. I can reach the final state with 1A. I can reach the final state with 2 A's. I can reach the final state with 3 A's. Okay, if I get another A, that is a trap state, that should not be accepted. Okay, and there can be a number of B's in between. Moving on to the next one, we have prefix AB. Prefix means before any string I should have AB. That's my least condition. Okay, so what is the least string? I can have an empty string here with the prefix AB. So my least string is AB. So I should design the automata for AB. So I'll have A here, then B here, it will reach the final state. Okay, so this is my least string, and after that I should design means A's and B's for each of these. Okay, for this A is over. If I get a B in the initial stage, I should go to the trap state, because if I get B initially, I'll get B also accepted, which is wrong. It should have prefix AB, so it must start from AB itself, no other string. Then A and B is defined for this one. For this one B is defined, but what about A? If I don't have trap state for A, what it will accept is, if I have like self loop here, it will accept AAB, right? I think that's possible. AAB is fine, because no, it's not, because I should have AB, right? If I get AAB, the prefix will be AA. That's wrong answer. So this is the correct one. I should not have AA in the initial stage, so I should have trap state for A. Okay, and then after reaching the final state, I can have any number of A's and B's. Okay, means AB is done here, that's sure. I've reached this state. After that, I can have any combination of A's and B's. Okay, so that was about the prefix AB. In the same way, we have suffix of AB. Suffix means at the last it should appear as AB. Before that, I can have anything. So what is my least string in this case? Same as previous one, I can have the least string is AB itself, right? So I'll have the least string here AB, and after that I can have any number of A's and B. Before that I can have any number of A's and B's. So in the initial stage, if I have like B here, see here, what we need is at the last I should have AB. Okay, that is satisfied here. Now I should see for other strings, means other alphabets for each state. For this, which all is defined? Just A is defined as of now. So what I need is I need to define for this state the transition for B. Okay, so before that I can have anything here, so I'll have a self loop for B. Then when it is over, I'll go with A here. Then in this B is only defined, right? So I should have a definition for A as well, right? What is the condition? AB it should end. So if I have a self loop A here, it will have n number of A's, then B. What is the ending? N number of A's and B means ending is also AB, so that's fine. So I have a self loop for A here. After I reach the final state, means AB is done. If I need to do further, like for this also I have to define A's and B's. So what I will do is, if I get an A, I'll come to this state. Okay, so what will happen? A I got, then I move to this state, then again I have to, if I want to reach the final state, I have to go with B. So again the string will end with AB. Same thing goes for B also. Suppose that in the final state I got B, so I'll reach to this state. So I got B, I reach this state, then A, B. I'll pass through AB again. So I'll have an ending AB. Okay, so before that anything will be there here, ending will be AB for sure. Okay, moving on to the next one, we have begin with A and end with B. So what are the possible strings? The least string is AB. So I have defined A here, then B here. This is my least string. After that I just have to see for other strings. What it should not accept is starting with A and ending with B. Suppose that it starts with B, at that time I should go to the trap state, and ending with B means it will have B here, and after that I self loop for B. Now if after this one another A comes, at that time I will come to this state, so that it always ends with B. Okay, and in between also we will have self loop for A and B. Okay, the next one is the second symbol is 0 and fourth symbol is 1. Okay, so what is the pattern like? The second symbol is 0 and the fourth symbol is 1. So here what are the possible strings I can have? The length will be 4 for sure. It can be no more than it's actually not given, we can have the longer length also, but just the condition is that second symbol should be 0 and the fourth symbol should be 1. After that I can have anything. Okay, so what is the least string? Least string will be like many combinations, just that the second symbol should be 0 only and fourth symbol should be 1 only. So what I have made here is, starting I can have 0 or 1. Okay, after that the second should be must be 0. If I get at the second position 1, I'll come to the trap state. After that the third symbol can be anything like 0 or 1. After that the fourth symbol should be 1 only. If I get a 0, I'll come to the trap state. Okay, after this condition is over, like a second symbol is 0 and the fourth symbol is 1. After that I can have the string of means how much length I want, and I can have a number of zeros and ones. Okay, so that was about the question which has a second symbol 0 and fourth symbol 1. The next one is a substring AB, substring AA. Okay, substring AA means at least one time AA should appear anywhere in the string. ABA is not acceptable, AA should be there together. Okay, so what is the least string? AA. So make a transition for AA here, A. After it had reached the final state, then make the transition for other symbols also. For example, what I have done here is, after you reach A, what is defined till now? For this only A is defined. If I get a B, I cannot move further because first I need to get A, means substring should be there, right? So first for B I will have self loop. For this A and B is done. For this, what about B? If I get a B here, I cannot move to the final state. Why? If I move to the final state, the substrings, means the sequence will be broken. After A, I'll get a B here, then I'll get an A and move to the final state. So what it will accept is ABA also, but I don't want it to accept ABA, I want only AA. So what I'll do is, if I get a B, I'll move back to the starting state, so that it will always have the possibility of AA after means in the future. Okay. So after it has reached the final state, I got a substring AA. Then after that I can have n number of A's and B's. Okay. The next one is not having substring ABB. See, the questions which are starting like not having a substring, at that time what you have to do is, you have to see here, you have to make the diagram for having the substring ABB. Make a diagram for this one. You will have A here, B, B. After you have made this one, just change the final states into non-final states and vice versa. Okay, these were the non-final states initially, and this was the final state for a machine accepting ABB, right? But if you want to like not accept ABB, you just have to change the final states. In these places it was not accepting ABB, so make it as final states. In this state it was accepting ABB, so make it as non-final state. In that way you will be making sure that it will not accept the substring ABB. Okay. The next one is L is equal to A and W will have n number of A's and B's, and then again ending with A. Basically it's starting from A and ending with A. In between you can have anything. Okay, so what is the least string? AA. In between I don't have anything. Okay, so that is the least string. So AA, how I'll represent AA. If it's starting from B, come to the type state, else and in between I can have anything, right? So it will have B's here and A is going here. After that, if I want to extend, like for example AA, A, B, okay, and ending with A. So how can I get AA, B? So for A I came here, then another A I reach the final state. If I don't have another transition for B, my string will just accept this one. So I should have some possibility of accepting this one also. So how will I make sure that is? For this also define what is A and means where I should go for A, where I should go for B. Okay, so for A it's ending with A, so I can have a self loop here, so always it ends with A. What about B? If I get a B, I'll come back here in this state, so that again I can have n number of A's and B's here, and again when it's over I'll move to the final state on A, so I'll end with A. Okay, so that's how you'll see and design from which state to go to which state. Okay, the next one is the length of multiple 2, 3 and not 5. Okay, so let's discuss each one by one. Length a multiple of 2. Okay, I have AB here. Is this a multiple of 2? What is the length of this string? 2. It is a multiple of 2. What about ABBA? It is also a multiple of 2. What about ABA? Is it a multiple of 2? No. So my machine should not accept ABA, but it should accept the strings which are multiples of 2. Now how to design this one is, first you will have multiple of 2 means what? Even, right? If it's even length, it should accept. So here I'll have two states. Even means 0, 2, 4, 6 and so on. So accepting 0 here, that also should be there. So my starting state will itself be the final state. Okay, after that it should accept 2. 2 means I should go and come back, so I'll get 2 here, again go and come back. Whenever I reach the final state, I'll have plus 2, again plus 2, again plus 2. So I'll make sure that whenever I reach my final state, I have passed even number of times, right? So in the iterations also there is no constraint like you should have even number of A's or even number of B's. The total length should be even, like A, B, A, B. The total length should be even. You can have all A's also, all B's also, or combination of A's and B's also. Okay, so in that way I can have A's and B's here, anything you can go, again come back with any of the letters. So just that the length should be multiple of 2. In the same way you have to do for multiple of 3 also. In multiple of 3 we'll have 3 things, 1, 2, 3, come back to the final state. 4 should not be accepted, 5 should not be accepted, 6 should be accepted, so I'll come back here. And since it's the multiple of 3, 0 is also multiple of 3, so you'll have the state which is the starting state as the final state. Okay, So yeah, that's what we have to make here, and there is no constraint like A's and B's as in the previous one. So we'll have A's or B's here, means both can be used. Just the length should be multiple of 3. Okay. The next one, length not multiple of 5. What I told you to make the transition diagram for not the multiple of 5. First make the transition diagram for multiple of 5, then make the changes. What I mean is, for multiple of 5 you will have length of 5, right? 1, 2, 3, 4 and 5. It will come back to this state, it's the final state. So don't make this as the accepting state, make rest of the things as accepting state. So it will accept 1, 2, 3 and 4. That's what we want. Length not multiple of 5 should be accepted. So 1, 2, 3 and 4 will be accepted, while multiples of 5 will not be accepted. Okay. Moving on, we have always ends with B. Whatever my string is, it always ends with B. So what is the least string? B. So I have a transition from Q0 to Q1 on B. Okay. So it will accept B. I can have a number of B's here because it will end with B. If I get A, I'll come back here, and in this loop I should always end with B. So if I have to reach the final state from this one, I'll pass through B for sure. So I'll make sure that whenever I reach the final state, it is getting passed through B. Okay. And A's will have a self loop here. The next one is not ending with BA. First make it for ending with BA. So you'll have the least string BA. After that, make the non-final state as final state and vice versa. Okay. The next one is consecutive 3 zeros. The least string is 0, 0, 0. After that, you can have any number of A's and ones and zeros. And if you get a 1, come back here, because I should pass through 3 zeros consecutively. Okay. I'm getting a 1 after passing through 2 zeros. What I mean is, I've passed through 1 0, another 0. If I get 1, I cannot stay in this state, because what will happen? 0, 0, 1, then again 0, this will be accepted. This is a wrong string. Okay. First my condition should be over, then after that I can have like this. What I mean is 0, 0, 0 is there, 0, 0, 0. After that this condition is over, I can have the combination also like 0, 1, 0 and all. But this state should not come before happening of this one. Okay. That's all what you have to keep in mind. Okay. The next one is multiples of 2 in decimal. Okay. What are the multiples of 2 in decimal? 0, 2, 4, 6, 8. Okay. 0, 0, 0, 2, 0, 4, 0, 6, 0, 8. What about odd numbers? These are not multiples of 2. Okay. So here in this place I can have anything like 1, 2, 3, anything. That will not make any difference. What will make the difference is just the ending should be 0, 2, 4, 6, 8. So how will I do is that I have taken 2 sets here, because this is the even set, this is the odd set. Whatever my symbol, I can choose any symbol from here. Like let's take the symbol 0. 0 is an even number, so it should be accepted. So my starting state is the final state, and for all these 2, 4, 6, 8, it will be accepted, because it's the even number, it will be accepted. What if it's an odd number like 1, 3, 5, 7 and 9? If it's among these numbers, at that time what I have to do, I have to reach this state. This is not the final state. Okay, because it should not accept the odd numbers. Now what if my number is 12? Means an element from set B, an element from set A. At that time it should accept, right? So for B's I will go to this this side. Whenever I get A, I'll come back to this state, final state. Unless and until I get A, I'll not come to this state. Okay, because A should be accepted as the question is about multiples of 2 in decimal, so A should be accepted. Okay. The next one is multiples of 5 in decimal. Okay, multiples of 5 means 0 and 5 means the ending should be with 0 and 5. Right. The multiples of 5's ending is 0 and 5. The rest of the numbers should not be accepted in the final state. It can come before that, but it should not come after that. What I mean is 1 and 0, this should be accepted. 1, 5 also should be accepted, but 1 should not come after this one, and this should not be accepted. So I should make sure that whenever I reach my final state, I should reach either through 0 or through 5. So 0 and 5 I have taken the set as A. So whenever I am reaching my final state, I am passing through A and reaching. So if I get an means other number than multiple of 5, I'll reach this state, and that will be processed here, and after that whenever I get a 0 and 5, I'll come back to the final state. Okay. The next one is multiples of 3 in decimal. Okay. So listen here carefully. If I write the 3 table here, what are the numbers ending with which digit are multiples of 3? Like for 2 it will end with 0, 2, 4, 6, 8. For 5 it will end with 0 and 5. But what about 3? Does the decimal of means the number ending with 0 will be accepted by 3? It may not, right? Means 10 will not be accepted, 20 will not be accepted, but 30 will be accepted. And the same goes for all the digits. 1 also, 11 is not accepted but 21 is accepted, and 31 is not accepted, but I'm not sure about the next one, but that's the case here. 2, which one it's accepting? 12 is accepted but 22 is not accepted. So it depends. For all the digits you try, you will get that for some of the digits present here it will accept, and for some of the digits it will not accept. So I should make a slight difference here while making the diagram. Okay. So difference is that first let's write down the combinations. 0 0, 0 3, 3 6, 9, 12, 15. After writing the numbers, one thing you have to observe is these 3 digits are these first 4 digits are not leaving any remainder. The remainder will be 0, right? And these 3 digits will leave the remainder 2. Means you divide 2 by 3 you will get 2, 5 by 3 you will get 2, 8 by 3 you will get 2. So the remainders are 2. For 147 you will get the remainders as 1. So I can make 3 groups here. This is group A, this is group B, and this is group C. In group A the remainder is 0, group B the remainder is 2, and group C the remainder is 1. After making these groups, what you have to do is you have to make 3 states for remainder 0, remainder 1, and remainder 2. Now you have to make the transitions. For example, you are in this state and you get the input as 0. What is your remainder? Your remainder is 0. So you will remain in this state only. Okay, this for the remainder 0, and this for the remainder 1, and this for the remainder 2. So let's take another one. If you get 2, okay, if you get 2, what is your remainder? Means 2 divided by 3, what will be the remainder? I mean modulus here, you will get the remainder 2. 5 modulus 3, remainder 2. Any of these 3 elements you can take from the class. So if you get in the first state as 2, 5 or 8, at that time your remainder is 2, so you have to come to this state. This is the remainder 2 state, right? So you will come to this state. Same thing goes for the third state also. If you get 1, 4 or 7, you will come to this state. On C you will come to this state. This for the remainder 1. So that is for the single digits. Suppose what if you got 33? It is from the A. Here also you will get the remainder as 0. So which state you will stay in? Q0. Another element you can take from here, like 6, 9. Whatever element you take, always you will get the remainder as 0. So any number of A's I am getting as 0. I will have a self loop for A here. What about the next one? I have A defined here and C also defined here, and B also I got here. So A, B and C are done for Q0. Now come to Q1. How will I reach Q1 is from Q0 to Q1. Q0 to Q1 I am getting means this for the remainder 1. So for the remainder 1 I have chosen an element from this class. Okay. So suppose that the first digit here was 0, then I got second digit 1. After that I should choose every element from this class A, B and C, so that I can have transitions for if it is A, where I will go, what is the remainder, if it is B, where I will go, if it is C, where I will go. So in this state I should have the combinations of 3. Let's do for A. If I am in this state and I got the element from this class, where I should go. So let's take any example 3. Let's take for this one 5. Let's take for this one 4. So this for A, B and C. So on A I am in this state. If I get on A, where I will go? 13. 13 divided by 3. What is the remainder? 1. 1 means this state itself. So I have a self loop for A here. The next one 15. 15 divided by 3. Answer is means the remainder is 0. 0 means which state? Q0. So for B I will have a transition on Q0. What about C? 14. What will be my remainder? 2. 2 means which state? Q2. So if I get an element from a C class, I will go to Q2. Same thing you do for Q2 also, you will get in this way. C will go to here, and A, for A it is a self loop here, I forgot to make, and for B it will be for this one. Okay, so this is how you solve the question for the multiples of 3 in decimal. Okay, this is an important one. The next one is the multiples of 3 in binary. Okay, binary is a bit different but a bit easier. Okay, binary means what all you will have, zeros and ones. Now the thing is, whenever you get a 0, which state you will go? If you get 0 1, which state will go? If you get another 0 1, means this whole number, is it divisible by 3, what will be the remainder, which state you will go? That you have to define, and that you have to means show in this transition diagram. So let's start from here. Either you will get the remainder 0 or 1 or 2. These are the 3 possibilities. So for that you will have 3 classes here, for the remainder 0, for the remainder 1, for the remainder 2. Now suppose that you got 0. 0 means what is the modulus 3? That will be 0 itself, right? So you will stay in the same state on 0. What if you got 1? What is 1 modulus 3? 1 modulus 3 is 1. So you will go to this class which has the remainder 1. For this 0 and 1 is done. What about this state? In this state, how I reached from 1? So I got 1 here, then I have to define for 0 and 1. 1 with 0, 1 with 1. 1 0 means how much? 2. In binary, 1 0 means 2. So 2 means what is the remainder? 2 modulus 3, that is 2. So I will reach to this state on 0. Then what about this one? Here I have 1 1. 1 1 means 3. 3 modulus 3, it is 0. 3 modulus 3 means it's sorry, 1 1 means it's 0. So from this state, if I get 1, another 1, I am reaching to which state? 0's remainder state. So I am reaching to this state on 1. Okay, same thing you do for others also, like check the combinations and for each state define for 0 and 1. Okay, then you will get this transition diagram. Okay, the next question is at least 2 A's and exactly 1 B. So what is my least string? It can be either AAB, okay, AAB, or I can have ABA or BAA. These are my 3 least strings. Okay, there is exactly 1B and at least 2A should be there. So for each of these 3 least string I have to make the transition. Okay, so for the first 2 string I have in the starting state A, then I will have like A or B, then I have here for the first one I have B, for the next one I have A, for this one I have B, for the next one I have A. So in these 2 ways I can reach the final state. Then the last one is BAA. So for B I have here, then A, and here also it is A. So I am reaching through this state here. Okay, so now we will draw the exceptions. Like for each state we will check A and B is defined or not. For this A and B is defined, for this also A and B is defined, and for this one only B is defined, right? So what happened here is actually this was not there, this we'll add later. So how this came is for this initially it was A here. So for this I have to make for B. So if I make for B, what the string I am getting? A, B. If I add B, I am getting a string A, B. What is the next letter? At least 2 A's should be there, it should be accepted, and after that it should reach the final state. Adding an A and reaching the final state, where I have to go? Adding an A and reaching the final state will be possible from this one. Adding an A and reaching the final state. So I'll connect this one on B. So I'll get A, B, A. And for this one A, B is done, this also it's done. For this only B was there. For this what I am accepting? At least 2 A's and B. So I'll have n number of A's here. So what I'll have? N number of A's means I can have like A and all, and I'll have B. Okay, so I'll have a self loop here. Then what we are remaining with is, for this one A is there, what about B? If I get another B here, before only I got B here, if I get another B, that means it's a trap state. It should not have 2 B's. Exactly 1 B should be there. Okay, and from here, after I get in this state, if I get another B, that is also a trap state, because I have got B here, and if in this way also I have got 1 B, in this B also, in this way also I have got 1 B. Okay, so this will go to the trap state. Now what if after reaching the final state I get another B? That should also go to the trap state, like, because I have already got 1 B and exactly 1 B should be there. If I get another B after reaching the final state, it should not be accepted, it will reach the trap state. Okay, and I can have a number of A's because at least 2 A's satisfied here in each of these three cases, and after that I can have a number of a's. Okay. So that's how you will solve this question. And let's move on to the next one, which is WBAP. In this, W means n number of a's and b's. Okay, after n number of a's and b's, it should end with BAB. So my least string is BAB that I have defined here. After that I can have n number of a's and b's here. So for this state, for these three states I have to just define what will happen if I get a letter other than what is defined. B is defined here. If I get A, what should happen? Self loop, because I can't reach further unless I get a B here, because it should end with BAB. So for this one also I will see what is to be done, and for each of this state I will see and do. Okay, so this we have discussed how to do this one by seeing in the previous question, so I am skipping for now, and let's move on to the next question, which is ending with AB or BA. Ending with AB or BA means the least string is AB and BA. For AB I have, for BA also I have defined. After that I have to see what are the left out states. For this A and B is defined. Then for this also, for this B is defined but not A. It's ending with AB, so I'll have a self loop for A here. So n number of A's and B, that's also ending with AB. And for this also it's the same, BA it's ending, so I'll have a number of B's here, so it will end with BA. And for this A and B is done. For this also A and B is done. Now we'll reach the final state here. In the final state, if it is encountering A again, so what it should happen? Like for example, AB. After that it got another A. What it should end with BA, right? So if it's ending with, is it ending with BA? Yeah, ending with BA. So if I got another A here after this one, a slight change here, just cut what is present here and here, and what we'll have is, if it is AB, we'll reach this part to the final state. Okay, and if it is BA, we'll reach here and here. This is the new final state. Okay, and we have two final states. And what if the string is ABA? If it is ABA, what will happen is this also should be accepted. Why? Because it's ending with BA. Okay, so ABA will follow like this, A, B. If it is A, it will come here and accept this one. Okay, again if it is B, it will come here and accept this one. What if it is AA? Okay, at that time what will happen is, I have to define the transition for A here and the transition for B here. AA should not be accepted. So what will happen is, it will come back to this state here. So if A is coming here, what will happen is, it will again end with B. Same thing goes for B also here. If it is coming as B here, it will come to this state. Okay, so if it will end with B, then it will end with A, means from B, then it will end with A, like that it will happen. Okay, this is the change. What you have to make is, make a new final state on A. Okay, then make a cross here, then on A it is going here, and on B it is going here, and here you will have A and B. Okay, make this diagram in your rough sheet so that you will get a clear idea. Okay, like make it in your own way. This is a bit jumbled and cut here, and sorry for that. I didn't notice the mistake here. So let's move on to the next one, which is even number of A's and odd number of B's. Okay, even number of A's and odd number of B's means ABA should be accepted. Now one thing you keep in mind here, whatever is the odd number that you have to take first, it is odd number of B's. So odd number of B's means it should accept at least one B. So how you will make the transition diagram? Just for that, it should accept 1 B, 3 B's, and 5 B's, 7 B's, and so on. Okay, for that what I will make is, I will make Q0 here, then 1 B here, then Q1, then it will come back here for 3 B's and 7 B's, means 5 B's, 7 B's, and 9 B's, and so on. Okay, so this is the thing which you will make. This is the final state. That's what I have made up here. Now it should accept also even number of A's. What if it is an A here? Yeah, even number of A's. What if it is an A here? In that case, what will happen is, it will come to new state here, Q3 A. It will come back to this state A. It will have 2 A's, but only 2 A's will not be accepted. It should have at least 1 B, 3 B, or odd number of B's. So it should definitely pass through this one. So whenever I am in the left side, it will have even number of A's, but it should pass through this one to get the odd number of B's. Okay, so the diagram is as follows. I am starting from here. It's divided into 4 parts. if I am reaching this part here, it will accept odd number of b's. Okay, in the this is the upper row. Okay, upper row, and in the upper row I'll have the odd number of b's in the right side. Top right I'll have the odd number of b's. Okay, and even number of a's here. This is the odd number of a, and sorry, this is the even number of a. This is the odd number of a's. Even number of a and odd number of a, and here it is even number of b's, and here it will be odd number of b's, odd number of b's, and even number of a's. Okay, just make this diagram once or twice, you will get to know how it works. Like for example, if I have to accept a, b, a, okay, it is even number of a's, so what will be accepted is 3 a's at last. Okay, so what will happen? A, so it will come here, then b, it will come here. Okay, whenever b is odd, it will be in the right. Okay, b will be in the right whenever it is odd, and a will be down whenever it is odd. This you have to remember. So I have like one a and one b. I have to if I have to make even number of a's, I have to reach to the up. Okay, another a, it is even number of a, so I'll reach from a here. Okay, sorry, I am in this state here, so I'll reach the top from here, a. So even number of a's. Okay, so it is accepted, but the string is left, so another a is encountered. So again I have to come down, odd number of a's, then again I'll come up, even number of a's. So if the string is over, I am in the final state. Okay, so in this way also the other questions also can come, like even number of a's and even number of b's. In that also a slight difference should be made, but this is the most repeated one, even number of a's and odd number of b's. Okay, the next one is every a is immediately followed by a b. So wherever you have a in the string, it is immediately followed by a b. So you can have like this string, whenever a comes, it should be followed by a b. So what is the least string? A, b, right? So a will be here, then it should be immediately followed by a b, so b will be here. What if I get a, it is a trap. So a and b is defined for this one. For this one only a is defined. What if I get in the starting only b? So there is no constraint. If only b is there, it should be accepted. Whenever I get a, it should be with b. That is the condition. If I just have b, it will be accepted in the self loop here. Okay. The next one is a region should be of even length. A region means what? Wherever you have a here, that is of even length. Okay. For that, how I will make sure is, whenever I get a, I will make sure a is of even length. If I get after a, if I get b, it is a trap state, because a, b, a cannot be accepted. Every a should be of even length. In this case, a is getting odd length. If I get after a, if I get b, I will reach to the trap state. Else, I will come back with a, and after that I can have n number of b's. Okay. The next one is W has odd parity. Odd parity means odd number of ones. So how will you get odd number of ones? Starting state 1, final state. Next odd number is 3, so another one and another one. Next number is 5, another one and another one. This is the final state. Always I will get the odd number of ones, and the state should not change on zeros, so I will remain in the same state in both of these cases. Okay. The next one is I have to represent the the decimal number. So what is a means sample decimal number? It's given as -3.2 and e -6. This is the exponent and this is the decimal part. So how many parts we can make for this one? It can be plus or minus here. After that 3 is there, that's a digit. After that I can have a number of digits like 31, 32 and all. So for that self loop of d here. After that a point is there, for that the transition is there. I can skip the point also and reach to the exponent, like for example -3 e power -7. So for that no decimal is there, I can skip that one on epsilon. Else what I can do is if I get the decimal part, after decimal part also I can have a number of digits. So I have d loop here. After that e is there. Okay. After that minus sign, plus or minus, and another digit 6. So I have a digit 6 here. Okay. And I can have a number of digits after that, and this is the final state. Okay, Q7 I forgot to mention, this is the final state. Okay, you'll have two final states here, Q7 and Q4 also. Okay. The next one is all the 5 vowels occur in alphabetical order. So what does this mean is, it's not necessary that even if it is not appearing in the alphabetical order, but appearing also, like in two different cases. For example, A, E, I, O, U. This is the alphabetical order. This is the least string, so I'll have A, E, I, O, U. Now this is the constraint. If it is satisfied, after that I can have means any combination of letters here. But what if it's the case that E is appearing first, then I is appearing in between A and E? Will this thing be accepted or not? It will be accepted because there is a combination here, there is a sequence here in which I am getting all the 5 letters, all the 5 vowels in alphabetical order. That is the only constraint. Even if you have E here in different order, I still have another combination by which I can get all the 5 vowels in alphabetical order. If that sequence is there somewhere in the string, then you can have the different combination also. But what if it's the case that E, A, I, O, U, only this string is there? In that case it's not acceptable, because there is no combination in which all the 5 vowels are appearing in the alphabetical order. So to make a valid string, I have to add an E here, so that there is a combination here, the whole string will be accepted. Okay, that's what present here. This is the set of all symbols. Sigma means A to Z all, and I am removing A. Why I am removing A? Because A is getting means if I get A, I will come to this state. Except A, all the letters should be in the self loop. Okay, so the same goes for E, I, O, and U also. Okay, and the next one is before and after A there is a B. Okay, before and after A there is a B means wherever you find A in the string, you will have a B after it and before it. So here I have A here, before that and after that I have B here. So what is the least string? The least string is if I get a single A, B, A, B. That is the least string, right? So B, A, B. Okay, so after A, if I get another A, it will reach to the trap state. I cannot start with A directly because before that I cannot add B, because if A is the starting letter, I don't have a B here, so it should reach to the trap state. Except that the rest of the combinations are means made accordingly. Means we will see what is the string forming and in which state if I go, I'll get the correct answer. By that we'll add the other transitions. Okay. The next one is no two consecutive characters are same. So in this string it can be either A, B, and so on, or B, A, and so on. Okay, B, A, and so on. So these are the two possible combinations. It can start from A or B, starting from A or B. Okay, after A I must get B only. So if I get a B, I'll reach to the final state. Also only A and only B is also acceptable, right? Only A and only B, that is also final state. If I get a B after A, that is coming here, and in this state it's accepting. And if I get A after B, from B then A, I am reaching to the final state. What if I get AA or BB? If I get AA, at that time it will reach the trap state. If I get BB, that will also reach to the trap state. Okay. The next one is no more than 1B. No more than 1B means only only a single B should be there, and A can be n number of A's. Okay. So for that what we have is I'll have 1B here, I can have n number of A's, that will also accept here. 1B will be there, I'll come to this state. In this state if I get another B, I'll reach to the trap state, else I'll have n number of A's here. Okay, that was about the DFSM. The next topic is NDFSM into DFSM. Okay, so here first we will be given with the DFSM here, NDFSM here. NDFSM means non-deterministic finite state machine. Okay, so here what we have is for each transition like Q0, we'll have the same input. Okay, like A, it can go to Q1 also and Q2 also. So we have to convert this type of machine into a machine where Q0 will go to a single state, on A it will go to a single state, not multiple states. Okay, for that there are few steps. In the first question we have there are three states, Q0, Q1 and Q2, and the transitions on Q0 are A and B, and it's a self loop, and after that we have A to the Q1, and from Q1 we have to the B. Okay, so the first step is you have to make for epsilon transitions. So there is no epsilon in the transition diagram, so we'll move on further. In the further step I have to start from the starting state. Which is a starting state? It is Q0. So what are the alphabets A and B? So for both you have to write Q0 on A, Q0 on B. In which all states it's going? q naught on A is going to 2 states q naught q1, q naught on B is going to 1 state q naught. Okay, so after you have written this one, then your next step is you have to find out the new states. The new state is q naught q1, right? You had q naught only, the new state is q naught q1, so you will make the transition for q naught q1. Okay, this is just for the reference I have made, q1 on A and q1 on AB and q2 on AB. This you can skip for now, you can start from here, but this will be useful when you are doing this one. Okay, so for q1 q2 q naught q1 on A, q naught q1 on A, what is the set? How you will do that is, what is q naught on A? That is q naught q1. Then q1 on A, q1 on A is not defined, so it will be means phi, and you will take the union of both of these, this for q naught and this for q1. The union of both of these will give me q naught q1. Same thing goes for B also, q naught on B is q naught itself, and what is q1 on B? q1 on B is q2. So I will get the state q naught q2. After I have got this state, I have got two states here, q naught q1 and q naught q2. This is already done, I have made the transition. What about q naught q2? That is the new state, I have to make the transition. So I will make the transition in the same way for A's and B's. I will get the answer here. If I get no new state here, I will stop there and I will see how many classes I got. I started from q naught, so I have taken this as A. Then I got the new state q naught q1, that is taken as B. Then I got the new state q naught q2, that is taken as C. After I got A, B, C, one thing I have to do, for each of A, B, C, I have to draw the transitions on each letter A and B. For example, q naught, there is the class A which is q naught. So what is q naught on A? Q naught q1. Q naught q1 I have taken as B. So this class which is A on A, it will go to B. Okay. Class A on input A, it will go to B. So class A on input A, it will go to B. Same thing you have to do for all the other classes also. You have to see from the means up what you have written here, the transitions are written on A and B for each class. In that way you have to see and make the transition diagram. Okay. The next question is, here we have the epsilon transitions. So we will see what is the epsilon transition. Whenever we have epsilon transition, we have to make the possible states which it can go. For example, what is epsilon closure of q naught? Epsilon closure of q naught means through epsilon which all states you can go. Firstly, the same state q naught will be written. After that, through epsilon I can go to q1, I can go to q2, I can go to q3. So I have written all the states here. In the same way, from q1 in on epsilon, where all you can go? q1, q2 and q3. Same way for q2 and q3 also. After you have written this one, if you see, there is no alphabet here. So this is the final diagram, because there is no input alphabet, so we can't make any transitions, it will all be like null transitions. So let's move on to the next one, which is in this question we have both the epsilon transitions as well as A and B. So let's see how can I solve this one. What is your first step? Your first step is to make the epsilon closure. So we'll write epsilon closure for each of these states. What is epsilon closure for q naught? For q naught, where all I can go in epsilon? Q naught itself, on epsilon I can go to q1, and here also epsilon is there, I can go to q2 and I can come back q naught. So q naught is already written, so this is my state, q naught q1 q2. So epsilon closure for q naught is q naught q1 q2. Same thing you will do for the rest also, q1 q2 and q3. So you will get the epsilon transitions here. After you get this one, what's your next step? Check which are the alphabets A and B. So this is the starting state, start from here, at the transition q naught on A, where you will go, which all states you can go. Then q naught on B, which all states you can go. For example, the first one is q naught on A, where all I can go. Actually the A is coming from here, so this is not the transition for q naught. Q naught on A, I am not going anywhere, I am remaining in the same state because there is no transition for A here. So q naught on A will be but I have the epsilons also, right? So q naught on A directly it will be null, okay, it will be phi, but I have the epsilon closures also, like I can travel from here to here without any input alphabet. So I can check from here also, on A where all I can go, I can come back here. So which is the state? Q naught. And from here I have reached here, so q naught is there, and from here I can go to here also on epsilon. So what I am trying to say is epsilon I went here, again epsilon I went here, again I will check A I can travel anywhere or not, no, I will come back here, from here A anywhere I can travel or not, no, but I had got from here A. Okay. Now one thing we need to keep in mind is whenever you get a transition for A, you have got A, you reach to this state. Now from this state where all epsilon will take you, all those state will be included. Okay, you started from here, epsilon went here, but you will not take this now because A is not yet found. When A is found and you reach to some state, after that all the epsilons will be included. So you have reached this state, Q0 you will write, from epsilon you can go to here, Q1, again here, Q2, and you will reach back here, Q0. That's already written, so I will not write that. So Q0, Q1 and Q2. So I will write here Q0, Q1 and Q2. Same thing goes for B also. So let's do one more for B and see where it goes. So Q0 on B directly it is not there, so I will use the epsilon. I will not yet write down Q1 because I have not found B yet. So whenever I found B, after that I will start the epsilon, means I will include the epsilon states. So I have not found B, then I can go from epsilon to here, and B also I can go. So whenever I found B, I reach to this state, I will include this state, Q2. After that I will check where all I can go from this state on epsilons. I can go to this state, so include that state here. Again from here I can go to this state, include that state here, and from here again I am coming back to this state. That's already included here, so this is my state, Q0, Q1 and Q2. So I have written here Q0, Q1 and Q2. In the same way you have to do for all, and after you have done for Q0 on A, Q0 on B, you have to see which state you are getting. You got this is a new state, Q0, Q1 and Q2. So you will take this state here and you will write here Q0, Q1, Q2. Then you will see the transition on A as well as on B. Okay. Since like on A only I got the whole transition, so obviously I will get for each of these union also I will get the same transition, right? For B also it's the same thing, I will get the same transition. So this on A and B will give the same. So I have a self loop here for A and B, and for Q0 on A I am getting to this state, as well as for B I am getting to this state. So this is the transition diagram. Okay. In the next one we will start from Q0 here, we will write the epsilon closures. From Q0 I am not going anywhere on epsilon, there is no transition for epsilon here, so I will have just Q0 here, and for Q1 I have the epsilon transition here, so it will be Q1 and epsilon transition here, so Q2, and from Q2 I do not have any epsilon transition, so epsilon closure of Q2 is Q2 itself. After I have written this one, start from the starting state. In this where all I can go on A, where all I can go on B. On A I can go to this state Q1, so Q1 I will write here. Then after that I can once I have found A, after that wherever I can go through epsilon from this state, that all I will include. From epsilon I can go to Q2, so I will write comma Q2. From this there is no more transition. So what I have Q1 Q2 for the first one, Q0 on A, Q1 Q2. The next one is Q0 on B. There is no transition for B, so it will be null. Same thing you have to do for the next ones also. The next what you will consider, this is the new state which you got, so you will consider Q1 Q2. Right here Q1 Q2. Okay, this I have made for the reference. You can start directly from here. Write Q1 Q2 on A, Q1 Q2 on B. Which all state you can go. If you find a new state, make it or make the transition for it. Else stop the problem there. Then see how many states you have. You have Q1 Q2. You have Q0 here, and yeah, that's 2 states I guess, and then this is the trap state. So in the 2 states you will see Q0 where all you can go on A and B. You will make accordingly. You have written here already for Q0 on A and B. See this and see this equation and make the transitions. Same goes for the next one also. Q1 Q2 on A and B both you have made. Which all states it is going, make that transitions. Okay, so that's all about the 4th question. And the 5th one also the same thing. See the epsilon closures and make here means on epsilon where all it's going, and after that start from the starting state. Whenever you get a new state, make the transition for that, and when you stop getting new states, you stop the transition there and make the state for each of these group which you got, and the final state will be where all the final state is included. For example, here the final state is Q2, so which all classes you have Q2, make that as final state. Okay, and make the transitions accordingly. Means this state on A where it's going, that you have already written up here, see that and make the transitions. Okay, that was about the fifth one, and in the sixth one also it's same, you can go through it. Epsilon closures and transitions on each of these, and you have the states here. So if you get any doubt in the question, just put up email to me, it's in the description box. So if I get time, I'll reply to you. Okay, so these are the final answers for each of these questions. And the seventh one is a bit different. So here what we'll have is just the table is given, so you just have to look the table and make the epsilon closures. So in the first column you can see there is epsilon closure here. So see for P, where all you can go Q and R. Okay, actually you have to include P also here, because means epsilon closure for the same one will be first this one only. So P Q R, and for Q it will be Q, for R it will be R. Okay, it's given in the table. Then you have to start making from the starting state. P is the starting state, P on A, P on B, P on C. P on A where it's going in the table is given, it's null. P on B where it's going to Q, P on C to R. So since the epsilon closures of Q and R are itself, we will not add any states. In the next one we will add Q on A, means where it's going according to the table, it's going to P. See Q on A, if you see the table, it's going to P, and we'll see where all P can go through epsilon. Through epsilon P can go to Q and R, so I'll add Q and R also. Okay, same thing goes for B and C also. Check if a letter is there through which you can go to other states through epsilon. After reaching the first letter, then add those states. For example, what I did here is QA, I reach P, from P I can go to epsilon, through epsilon I can go to Q and R, so I added Q and R. Okay, then see which all the new states formed here. Using those new states form the means find out the union and write the answers. When you stop getting the new states, and at that time you have to make the transition diagram. Okay, and the eighth question is also similar, and ninth question is also the same one. Just go through these questions and practice. And this is a bit different one. Let's see what is in this question. Here we have total 9 states, and we are starting from the starting state 0. Okay, so what is the first step I told you? Make all the epsilon closures. Okay, so for each of these states make the epsilon closures. So from 0 where all you can reach through epsilon. 0 itself, so I have written 0 only. From 1 where all you can reach, 1 on 1 itself. From 2 where all you can reach. From 2 I can reach to through epsilon. See here, observe carefully and note down what all I am telling the states. Okay, so 2 is here. Okay, from 2 on epsilon I am reaching 3. From 3 on epsilon I can reach 4, and from 3 on epsilon I can reach 6 also. Okay, so 2, 3 and 4, 6, and there is a transition here to 9 on epsilon, so include 9 also. Okay, so these are all the states which I can reach through 2. So that's what I have written here, 2, 3, 4, 6, 9. After that do the same thing for 3 also, and all the remaining numbers. After you have done that, your next step is to start from the starting state. Okay, in the starting state we have 0. Your task is to find out the transition for 0 on A and 0 on B. What is 0 on A? 0 on A I am getting to 1. 0 on B I am going to means no state, so it is null. So you will have 1 and null. Okay, so for 0 on A and 0 on B you have 1 and null. So what are the new states you got? This is the new state 1. So from 1 on A, 1 on B, where all you can reach. Okay, so 1 on A is null, 1 on B I can reach to these states. How I got these states? Observe carefully. 1 on B we need, right? 1 on B I reach 2. After I have reached, I have to see from epsilon transitions where all I can go. I can go through 3, 4, 6 and 9. So I have written 2, 3, 4, 6 and 9 on 1 on B. 2, 3, 4, 6, 9. After you have got this one, take this state as a single state, 2, 3, 4, 6, 9. Find out the transition on A and B. So 2, 3, 4, 6, 9 transition on A will give me these states. Let's see how it is. 2, 3, 4, 6, 9 means what is the first number? 2, 3, 4, 6, 9. You have to find out where all I can go on A through 2, 3, 4, 6 and 9. Then do the union and write the answer. From 2 on A, where all I can go? On from A I cannot go directly here. I will go to epsilon. So until I get A, I will not include the states. So I will not include any states here. Let's see, let's note down the answer here, final answer. So 2 I will not include, epsilon 3 I will just keep on searching. Whenever I get A, I will stop here. I got A on which number? 5. So I will write 5 here. After that epsilon I went to 8, so I will write 8 here. Then on epsilon I went to 9, I will write 9 here. Also on epsilon I came back to 3, so I will write 3 here, and from here I went to 6 as well as 4, so I will write 4 here. So that is all where all I can go through 3, and this is my answer: 5, 8, 9, 3, 6 and 4. 5, 6, 9, 3, 8 and 4. So this is my sorry for I'm doing for this one, right? Yeah, 5, 3, 9, 5, 6, 9, 8, 3 and 4. So this for A transition. Let us see for B transition. For B transitions you have to be very careful in writing the numbers, because epsilon will be included also, not included also. It just depends on whether you have found B or not. See, observe carefully, you are in 2, you have to find out for B, right? So for B, where I am going, on epsilon I am going to 9, until I find B I will not include any states. So my final answer will be here. So I have reached here, I am searching for B here, I did not get B, I got B here. Whenever I get B, that is the 7th state, so I will write 7 here. Then on epsilon I will reach 8, so I will write 8 here. I am getting to 9, I will write 9 here. Also from 8 I am coming back to 3, so I will write 3 here. From 3 I am going to 4, I will write 4 here. From 3 I am going to 6, I will write 6 here. So what is the number? 7, 8, 9, 3, 4, 6. Okay. So 7, 8, 9, 3, 4, 6. So this is the answer for the transition on B. It is just for 2. This answer is just for 2. Like that you have to find out for 3, 4, 6 and 9. But if you find also, you will get the same answer itself. So I have just written the final answer here. Okay. And which is the new states you got? This is the new state, this is the new state. So write down the new states here and do the same thing as I have told just now. What you have to do the same things, and if you get a new answer, make the new state. If you get the same answer, just stop there. Now this was done for this new state, this is remaining. So I will make this one also, and I will see if I get any more new states. I don't get any new more new states, so I will stop there. And which are the classes I got? I started from 0, so 0 is included. Then I went to 1, 1 is also included. Then I got the new state 2, 3, 4, 6, 9. That's a new class. Then after that I got 2 new classes starting from 5 and 7. So total 5 classes are there. Okay. So that I have written here, and make the 5 classes, and the transitions also you have written up. Means up only you have written the transitions on each class for A and B. See the transitions and make the transitions here accordingly, and wherever you have the 9, because 9 is the final state in the given question, wherever you have 9 in the set, make that as final state. Okay, this is a very important one because it's repeated a lot of times. Okay, make sure you solve this one before going for exam. Okay, the next one is also similar. The 11th one, you will write the epsilon closures here. Whenever you get new state, make the transition transitions for the new states, and when you stop getting the new states, make the transitions. Okay, so that was about the non-deterministic to deterministic FSM, and the next topic is minimizing DFSM. Okay, so here you will be given a question. So check the questions which I have written on the top. So let's go there where I have written here. It's page number 4. Okay, see here, these are the type of questions which you can expect. Means this is the pattern of asking. So you will be given with this diagram here, and you will have to minimize this diagram. Okay, so how you will do that is in the few steps. Write down this diagram or open the PDF in a different device so that you can see the question also. So let's move on to the solution part. In the solution part, first you have to differentiate between final state and non-final state. In the given question, which is the final state and which is the non-final state? The final state is Q1 and Q3, right? The final state is Q1 and Q3, which is of double circle. right? So that is the final state, which is a set of non-final states, all the states except this one. So right here, that's your first step. Okay, what you will do, you will separate the final state as well as the non-final states. Okay, after you have done that, what are the alphabets? A and B. Then take each element from this one and write the transition for A and B. First you will write for A, then on the right hand side you will write for B. So Q1 on A and Q3 on A, where it goes? Q1 on A and Q3 on A, it goes to Q2. See the diagram and make the transition here. Means write the transition. Q1 on A, it is going to Q2, so write here Q2. Here also Q2. If you get the same answer here, it is no split. Okay, you will get to know what is split. Okay, so after you have done for this one for A, next you have to do for B. In B, if you do Q1 on B and Q3 on B, it is going to Q4 and Q6. Now this is not same state, right? Q4 is different, Q6 is different. Still it is called as no split. Why? Because in which class does Q4 and Q6 belong? Q4 belongs to this one and Q6 also belongs to same class. When the answers belong to same class, it will be called as no split. Okay, that's your first step. You have made for the final states and you got no split here. Fine. Then you have to make for this one also. For each of these element here, Q2, Q4, Q5 and Q6, make the transitions for A and B. See the diagram and write down the transitions. So when you write down transitions, 4 for on A, 4 transitions are there from 4 states, and on B also 4 transitions are there. Now observe one thing carefully. What are the classes we have? Q1, Q3 on the first class and the remaining on the second class. If I have Q1 on Q3, that I will mark as first class. So see here, I have written the transitions for non-final states on A. I got this one as Q3, Q5, Q6 and Q5. This is a different class. This is the class 2. This is the class 1. When I get different classes for the same alphabet, at that time I will say it as split. Okay, just keep in mind it is a split. Whenever you get a split, your first task is to which is the state getting split. It is not Q3, it is this one. Q2 is getting split and it is different from Q4, Q5 and Q6. These were the same class initially, Q2, Q4, Q5 and Q6, right? These were the same class members. Now Q2 is getting split here because it is getting a different class output. So you will separate Q2. What does separating Q2 mean? Separating Q2 means you just have to take Q2 out from here as a separate group, and Q4, Q5 and Q6 will be a separate group. Okay, so the new classes will be Q2 will be out here, and as of now Q4, Q5 and Q6 are one class, Q1 and Q3 are another class. Okay, now we will be checking for this one, like Q5, Q4 and Q6, whether they are getting split or not. On the transition A, they are not getting split, but what about the transition B? We should check for B also. In B, what happens is you are getting Q5 here for Q2, and we are just concerned about this one because this is already split. Okay, so in these three cases, Q1, Q2, Q3, this is a separate class. Q2 is in a separate class, Q1 and Q3 are in a separate class. So therefore what is getting split is Q5, because Q5 is getting a different output than Q4 and Q6. These two got the same output of the class and this got the different class output. So Q5 will be separated. So that's why I have separated Q5 here. Then Q4 and Q6 are the same class, so it will be same only because it got the same output. Okay. So when you have the classes ready, what you have to do is you have to make the state for each of these. Like Q2 will be in a separate state, Q5 in a separate state, Q4, Q6 and Q1, Q3. And the final state will be that which has Q3. Okay, because Q3 is in the final state. Right, Q3, the set of final states are Q1 and Q3. Okay, both are the final states. So wherever we find Q1 and Q3, at that place we have to make the final state. After that, just looking at about the transitions in which class it's going, we'll make the this diagram, minimize DFSM. Okay, coming to the next one. Here we have been given with a table, and in that table D is the final state. Okay, only D is the final state. So what is the first step? I told you the first step is you have to see the alphabets. What are the alphabets? 0 and 1. You have to see the transition for D on 0 as well as D on 1. What is D on 0? D on 0 is D only. According to the table, it's D only. What is D on 1? It is A. So since we got only a single letter, there will be no split here. Okay, so the split will only be when there are multiple cases. Okay. Then we'll be checking for each of these symbol here on 0 and 1, means A on 0, B on 0 till H on 0, then A on 1, B on 1 till H on 1. Okay, that I have written here. Then we will be seeing which is the different class. These two are getting D, that means C and E will be split. These all are in the same class. Okay, so what is split as of now? C and E. C and E was initially in which class? This class. From here, if I remove C and E, the remaining class will be A, B, F, G, H. Then I have to check for this one whether there is a split or not. A, B, F, G, H. See here, A, B, F, G, H. Here it's in the same class, but what about 1? In 1, I should not include these two because these are already split. I can ignore this one. I am just concerned about this one. Okay, so here what is the letters I am considering? For on the transition one, I am considering A, B, F, G, H. Okay, so see here, A and B and F, G, H. Here what is the class? A, C. Whether A and C are in the same class? A and C, yes, it's in the same class. So these two are correct. And E is also in the same class. G is also in the same class, but D is not in the same class. So what's happening is H is getting split here. So if H is getting split, what are the different classes now? H is another class. C and E is another class. A, B and F, G are in the same class. Now we have to check A, B and F, G whether both are in the same class, means in the transitions, whether they still lie in the same class after H getting split or not. Okay, so A, B, F and G we will check. So A, B is here, A, B, F and G. A, B is in the same class and GF is also in the same class. So there is no split in the transition 0. Coming to transition 1, A and B are coming to AC and F and G are coming to EG. Okay, EG is also in the same class, AC is also in the same class. So therefore there is no split in A, B, F, G. Okay, so that is one class. D is another class. H and C, comma E is another class. Okay, so you will make the states for each of these and make the transitions according to what you have written above. Okay. Coming to third one, here we have the diagram and just make the follow the same steps. Make the draw the final states here and non-final states. The transitions on A for the final and non-final states. First check for the final state. It will be like if it's a single final state, you will have no split here. And for the non-final states, wherever you get a different class, split it and again check if after splitting also the remaining ones belong to the same class or not. Like that you will keep on checking until you get no different class, and after that you will stop and make the transition diagram. Okay, same thing goes for this question also. Here it's a bit like a slightly bit difficult, and means if you go through it very slowly you can get the answer. Okay, but be very careful. Okay, so yeah, that's all. The methodology is same here. Coming to the next question, we have here the starting state is A and final state is D. So sorry, final state is C. Okay, it's not D. Here it's actually C. Okay, this is the final state, and except C, all the other states will be taken as non-final states, and you will do the transitions here, and after that when you get no splits you will make the transition diagram. Okay, and the next topic is about the finite state transducers, and the first question is write a short note on finite state transducers. What is a finite state transducer is, you will have two tapes here. Okay, you will read the input from here, means there will be ones and zeros, right? And here you will write the output. You will read the input from here, and based on what answer you get, you will write the answer in different tape. So that's basically the working of finite state transducer, and you can go through the theory part here. If I mark the important points here, it is a finite state automaton which produces output as well as reading input. It produces the output and reads the input at the same time. Okay, and it consists of a finite number of states. Okay, like Q1, Q2 and all, and the transitions are labeled with an input output pair, and it is designed to start with a state and jump to different states depending on the input. Okay, based on the input it will change the states while producing the output according to the transition table. Okay, so that's all what you have to write in the finite state transducer. And the next question is, there are two parts here. Sorry, actually there are three parts here. First we will discuss the questions on Moore machine, then we will discuss the questions on Mealy machine, and then we will discuss two questions on how to transform Moore machine into Mealy machine as well as Mealy machine into Moore machine. Okay, so all of these questions, these type of questions have appeared, so let's solve each of these questions. Okay, so first topic is about design a Moore machine which accepts a set of all strings a, b and prints 1. Okay, listen carefully, it prints 1. When it will print 1, it will print 1 as the output for every occurrence of ABB as the substring. If the substring is ABB, at that time it should output 1, for example, otherwise it will output 0. Okay, if this is my string A B, at this case when I get only A, 0 will be the output. When I get AB, it will be 0. When I get ABA, it will still be 0. Here also ABAB, it will be 0. Here I will get ABA, ABB, ABA, BB. So here I got ABB, right, as a substring. So here I'll output as 1. Okay. So then if I get A, it will output as 0 because BBA is not a substring same as ABB. So like that we'll keep on going, and whenever we encounter ABB, we'll output as 1, else the output will be zeros. So how we're gonna solve this is the same thing what you have to make the DFSM. First the DFSM, the minimum string is ABB, so you'll make A, B, B. In the first stage you just have to make this one. Okay, starting state Q1, Q0, Q1, Q2 and Q3, A, B, B. Okay, after you have made that one, the only change you have to make in Moore machine is that in Moore machine inside you will make. Okay, remember, in Moore machine inside you will make. Inside you will make means what? Inside each of these states will mark the output. Here there will be no starting state, no final state. Only there will be there will be a starting state but no final state. Okay, the output will be here like Q0 comma 0. Why I have written here 0? Because I have just encountered a B or I have not started anything, so the output will be 0 initially. When I get an A here, still the output will be 0. When I get B here, AB, still the output will be 0. When I get in this state, that means I have passed A, B, B, so I should get a output as 1, so I have written here 1. Okay, so that's what you will do, the state and the output will be written here. Then you have to see the transitions for each of these. That's it. Okay, means for A it is defined, for B what I have to do so that it outputs the 0 value on B. So B can be taken as a self loop because what I need is ABB as a substring, so I cannot move further from here until I encounter A. So therefore I should make the self loop for B only. Okay, same thing as we done in the previous question for DFSM, same thing you have to apply here. Just one change is there, the output will be mentioned here here only. That's for the Moore machine. Moore machine, the output will be inside. Okay. So the next one is a Moore machine that takes the set of all strings over 0, 1 and produces A as output if the input is 1 0, ends with 1 0, and B as output when the input ends with 1 1, otherwise C. Okay, whatever the other combination is there, for that C. What is the two least string we can form? 1 0 and 1 1. So that's what we have made here. First 1 0, another 1 1. For 1 0 it will be A, and for 1 1 it will be B. After that you have to make the transitions, and rest all here and here it will be C, because whatever the other case is there, it will be C only. Then you have to make the transition accordingly. Okay, like unless and until I get 1 here, I cannot move further from this state because I need the string ending with 1 0 or 1 1. So 0 will be a self loop here. Like that you have to see for other states also. Okay, so just make sure that whatever transition you make, from that transition it should if it goes and if it ends with some particular string, for example here it's ending with 0 and 1, so 0 and 1 the output should be C, it is correct. Like that you have to check. Okay, and the next one is a construct a Moore machine which takes the binary numbers as input and produces the residue mod 3 as output. What is the residue mod 3? How many means the remainders you get when you divide a number by 3. Either you will get 0, 1 or 2. Now we have to design a Moore machine which take the input of binary numbers. Binary numbers can be either 0 or 1, a combination of both. Okay, so you will make 3 states here. This for the remainder 0, this for the remainder 1, this for the remainder 2. Now we have to see for each of this state you can have 2 transitions, either from 0 or from 1. So I have to define transitions for 0 and 1 for each of these, and your answer will be over. Okay, so how you will design is that here you have the output as 0. What binary input when you will get as 0. When you get 0, you will get as 0, means 0 mod 3 is 0. Then the transition for 1. If you are in the starting state, you got 1, at that time what is the remainder? 1 mod 3 is 1. So you will go to this state. This is for the remainder 1. So 0 and 1 is defined for this one. Let's come to this one here. In this, how you reach to this state? Only by traversing through 1. So 1 is already there. Then you have to define 2 things. For 0 where it will go, for 1 it will 1 where it will go. The input 0 and 1 on this state. If it is 0, 1 0 means 2. What is 2 mod 3? 2 mod 3 is 2. So on 0 it will go to the remainder 2. What about 1 1? 1 1 means 3. 3 means 3 mod 3 is 0. So it should go to the state 0 back. So for the one transition from this state, I have went back to this state. 0 and 1 is defined for this one. Then coming to the last one here, how I reach this state 1 0 1 0, then two possibilities are there, 0 and 1. On this state if I get as 0, what is 1 0 0? It is 4 mod 3 is 1. So on the input 0 from this state I will reach to the state which is the remainder 1. Okay. So what about this one, 1 0 1? 1 0 1 means 5 mod 2 5 mod 3 is 2. So when I get 1 0 1, I am getting remainder 2. So 1 0 1, the remainder will be in the same state 2. Okay. The next one is about the Mealy machine. In Mealy machine, just the difference is that instead of having the output here itself, you will have the output here. So let me explain you how this works. The question is, construct a Mealy machine that produces ones complement of any binary input stream. Okay. So let's take any binary number 10010. Now what is the ones complement of this one? Just change the zeros into ones and ones into zeros. Okay, this is the binary output, means ones complement of this string. Now how to make a Mealy machine for it? In Mealy machine you just have to like start from a state here, and whenever you encounter 1, what is the output? 0. You will come back to this state. Again you will see what is the input. If the input is 1, again 1, the output will be 0. Like that, if the input is 0, the output will be 1. Like that you have to make. Okay. So firstly it will start from here. So let me make a new one, 101. Okay. So first input is 1. So I came here, the first input is 1, I will go with this one. What is the output? 0. So it will output 0. Then it will move to the next one, 0. If it is 0, output should be 1. Then again it will come. The next one is 1. So if it is 1, the output should be 0. 0 1 0. Okay. Just a single state is enough, so I have not made any new states. Okay. That's how you design a Mealy machine. The next one is construct a Mealy machine that produces 2's complement of any binary input string. Assume that the string is read from LSB to MSB and the end is discarded. So what is 2's complement? For example, if I have the let's take a string here 10010. Now what is the 2's complement? 2's complement is nothing but first find out the 1's complement and after that add 1 to it. Adding 1 to it, what I will get? 1 plus 1 0, carry 1 1 1 1 0. Here I got 0 1 1 1 0. These are 2's complement of the string 10010. One thing if you observe here in this part, okay, wait, let me change one color. See, this part and this part is same, isn't it? And then after this part, this is getting the reverse. Means wherever you find 0 in this part, you will have 1 there, and wherever you find 1 here, there you are getting in here you are getting as 0. So that is getting reverse here. So when is the reverse happening? It's happening after the first one. When I encounter the first one, after that whatever is there, it will get reversed here. Till I encounter first one, including the first one, everything will be same here. So that's just the trick. Okay. Whenever you encounter first one, after that you have to make the change. Okay, that's all what you have to do. So I'll be reading the input from here. Okay. So see, there is the Mealy machine for it. First, if you get as 0, you will be writing here 0 only. So I have the state here 0, output is 0. When you encounter 1, the output is still 1. No matter how many zeros are there, it will have the same zeros. When you get the first 1, that will be kept as same 1 only. After that, the change will be made. So for 1, it will be same, but I will change the state because I have to alter the bits now. Right, here the bits were same, so I was in this state. Now the bits should be altered. I am coming to next state. In this state, whenever I get input as 0, what I should get the output? 1. So here the output is 1. If I get a 1 here in this state, I should get the output as 0. So I have written the input as 1, output as 0. That's all the Mealy machine in this case. Okay. So moving on to the next one, what we have. Construct a Mealy machine that prints the A whenever you have 0 1 encountered in any binary string. So it will print A whenever whenever 0 1 is encountered. Suppose my string is 10100. So here it is just 1, B will be output. It is 0, B will be output. 0 1 is there, so A will be output. 1 0. B will be output, and 0 0 B will be output. So when I got A, when I got 0 1. So what is the least string I have? The least string is 0 1, isn't it? So I'll have 0 here, I'll have 1 here. For 0 the output is B. Whenever I get after 0, if I get 1, the output is A. So that's the least string which you have to make in the initial stage. After that you have to add the transition for rest of the alphabets. Like for here the transition is defined for 0 but not for 1. What about 1? If it is n number of ones, then 0, still the output is B only, right? So I'll have B here, and coming to this state, A is defined. What about B? For the sorry, not A and B, but 1 is defined. What about 0? For 0, if I get here, let's take a sample string. If I get a self loop as 0 here, then I end with 1 here. So what is the string which I get? In this case, a self loop 0 0 I am getting, so the output will be B only, because the output will be 1 only when I get output will be A only when I get 0 1. Okay, if I get 0 zeros, it will be B only. So I have the output as 0 B. Okay, so that was about the transition for 0 and 1 here. Coming to this state, the transition for 0 and B in the same way. I am getting 1 from here. If I get a 0, if I get a 1, what I should do? If I get a 0, if I get a 1. If I get a 0, the output will be B only, obviously. If I get 1 1 also, it will be B only. But which state I should go, that's the main question. So for that, one trick is there. If you have to go from here, like on 0, where you find the self loop for 0, go there. Okay, you're getting 0 here. From here, go to the self loop part of 0. For 1, go to the self loop part of 1. So that you will get another, like from 0 1 ending, you will get a chance. So if you come from here 0, then you can either go here as 0 1 on A, else you can go here 0 0 on B. So what if I take like here I have 1. Whenever I get an input as 1 after this state, what is the thing here? See, what I mean is, if I get 1 from here, okay, I reach this state. So my input string was suppose 0 1. Okay, I got 0 1 here. Then again, if I get the input as 1, at that time I am going to here. Now there might be a question arise in your mind like, why I didn't go to this state here? If I go to this state, what will happen is, I'll be here. Okay, let's suppose I got another one. I reach to this state. Then on another one, I'll reach to final state, and the output will be 1. So on 1 1, I am getting the output as A. That's not what I want. I just want 0 1, the output should be A. So I am getting the wrong output. So for that, we have to check whether which state I am going through, that what output I am getting is correct or not. Based on that, you have to make the transitions. Okay. Moving on, we have the next question. Construct a millimachine for the binary input sequence such that if the substring is 101, the output should be B. Else if it's 110, the output should be A, and otherwise it should be C. Okay, so sorry, it's like the different one. 101 it's A, and 110 it's B. So what we'll be doing is, the two least string are 1 0 1 and 1 1 and 0. Okay, so in these three cases, first you will get A here finally, you will get B here finally. Okay, so rest means other than these three cases, you will have to define for C. Okay, then for each of these states, you have to define for what you will get the output, like for the transitions other than 0 and other than what is defined. Okay, so in that way you will get the diagram. It's a pretty easy question, so you will get the answer easily. And the next last topic is about the conversion. How to convert a Moore machine into a milli machine. The question is that convert a Moore machine to milli machine which count the number of A's mod 3. A's mod 3 means I have suppose that A, B, A. So B is not there. So in these three strings, what is the answer I get? Here I will get as 1, here I will get as 2, here I will get as 1. So that's what I have defined here. It's a Moore machine here. Here I will have 0, 1 and 2. For 1 0 you will get as means the remainder as 1, and for here you will get as 2, for the 3 you will get as 0. Okay, so that's the Moore machine. How you will convert this into milli machine? For that, only one thing you have to do. 0 is there, right? That 0 you will pick and keep here. 1 is there, you will pick 1 and keep here. 2 is there, sorry, not 2. What you have to do is, see, you will take from here, like what is a milli machine? In milli machine, just the input will be there, and on which transition what output you are getting, that you have to see. So I am in this state now. On the input A, I am getting the output 1, so A by 1. Then I am in this state. On the input A, I am getting the output 2, so A by 2. And I am in this state. For the input A, I am getting output as 0, so A by 0. That's all what you have to make. Okay. The next one is about the milli machine into a Moore machine. So here it's a bit complicated. See the diagram in your device. In that, what you can see is the first state is Q1. Okay, so let me show it here itself. See here, this is the state 1, this is the state 2, and this is the state 3. If you have to convert this into a Moore machine, the thing is that the output should be in the same state. Okay, so what is the difference? This state will be same only. Okay, this will be Q1. Okay, this will be same state only. Now on the input 0, what is the output I am getting? Z1. So what you will do is, you will come here, and the output what you are getting Z1. So in Q2 the output is Z1 and the input which you traversed is 0. Like this you will make first. Then on 1 I am getting the output as Z1. So in Q3 what I will write, on the transition 1 I am getting the output on Q3 as Z2, sorry Z1. Okay. After you have made the transition for 0 and 1 on this, then you have to see for this one. Here what you are getting, here for 0 what you are getting, I am getting the output as Z2. It's a different output, right? So if it is a different output, what you have to do is this one. If it's a different output, what you will do is you will take from this state 0 a different output, and on 1 a different output. On 0 I am getting the output as Z2. So I have taken on input 0, the state will be same Q2, but the output will be Z2. After that, on this state input 1 what I am getting, input 1 I am getting Z1. Okay, so it will be in the same state itself. Okay, but I am going to Q3, so it will go to Q3 and the output is Z1 and the input is 1 here. So that is defined for Q2. Now let's come to Q3. From Q3 I am getting the transition on 0, on Z1, 0, Z1 and the state is Q2. So do I have this state? Like on 0 Z1 and Q2, Z1 and Q2 is here. So from here on 0 where I will go? I will go to this state. Okay. So I have not defined for 0 here, I forgot to define. This is the transition. Okay. On 0 you will go to this state. Okay, that's for the Q3 on 0. What about Q3 on 1? Q3 on 1 where it is going? It's going to Q3 itself and the output is Z2. Okay. On the transition of 1 on Q3, I am getting to the state as Q3 itself and the output is Z2. So that's already defined here, Q3, and so it's actually not defined because I have Q3 Z1 as of now. So I have to make a new state here. On 1 it will go to a new state, Q3 and Z2. So we are done for 0 and 1 for this one as well as for this one. Now you have to do for this one. Here what is the state? It's Q2 on 0 and 1. Q2 on 0 it will go to Z2 and Q2. So this is the same state, self loop. And what about 1? For 1 it will go to Q3 Z1. So Q3 Z1 is here. So for, on 1 it will go to here. What about this one? On 0 where it will go? Q3 on 0 is Z1 Q2. So Z1 Q2 is here. It will go on 0 to here. What about 1? It will go to Q3 Z2. Q3 Z2 is the same state. So it will have a self loop on 1. Okay. Coming to module 2 of Automata, these are the topics which are present in the syllabus, but the questions which are asked in exam are from these topics. Okay, regular expressions, FSM to RE, either by heuristic or standard method, and RE to FSM, and closure properties and pumping lemma. Okay, so these are the topics from which the questions are asked. So let's discuss what are the questions in each topic. Okay, the first topic is regular expression. Okay, so the first question is, what is a regular expression? Means the definition of it. Okay. So it is a language, the language accepted by an automata is represented by a simple expression called regular expression. Okay, the language which is accepted by automata, it is represented using a expression. Okay, that is known as regular expression. Now the questions are as follows: representing strings of odd length. Okay, so odd length means the number of symbols used in it are odd. Okay, so for example it will be like A or B or BBB and so on. Okay. So what you can observe here is that if you want odd numbers, how will we get odd numbers? What are the odd numbers? First of all, the least odd number is 1, then we will get 3, then 5, and what you can observe here is that from 1 if you add 2 you will get 3, another 2 you will get 5, another 2 you will get next odd number. So 2 is getting repeated n number of times. So what I will do is I will have two symbols here, A or B, which can be repeated n number of times. If it's 0 time, it will not be repeated. 1 time it will be obviously there, like A or B should be there for 1 time for sure, because 1 is the least odd number. After that you will get, you have to add compulsorily you have to add two symbols, either A or B, and you can repeat another 2 times to get the next odd number. Like that we will be just representing the strings of odd length. Okay. The next one is to accept the string such that the third symbol from the right is A and the fourth symbol from the right is B. Let's start from the right. From the right, if the third symbol is A, so at that case this is the first symbol, it can be either A or B, second symbol can also be A or B, third symbol should be A, fourth symbol should be B, and after that any number of A's and B's can come before that. Okay. The next one is a power 2n and b power 2m. If n is equal to 1 and m is equal to 1, at that time what is my answer here? A power 2 b power 2, that means a b b. So if I repeat this once and repeat this once, because n is 1 and m is 1, at that time what I will get here? A b b. If I make it as 2, I will get here a 4 times and here I will get b b. So in that way I can represent a power n, a power 2n and b power 2m. Okay. And the next one is w mod 3 is equal to 0. Okay, the length of the string mod 3. Mod 3 means if the string is a and b, what is the length of the string? 4. 4 mod 3 is equal to 1. So if I get this string, the answer should be 1 and it should not be accepted, because the only strings which are multiples of 3 means the length of those strings who are multiple of 3, they should be accepted. So I'll have 3 symbols here which can be repeated n number of times. So if it is 0, it will be 0, that's also a multiple of 3. If it is 1 here, it will be 3 symbols. If it is 2, it will have 6 symbols and so on. Okay. The next one is languages of all strings of zeros and ones that has at least one pair of consecutive zeros. One pair of consecutive zeros means 0 should appear at least once. Before that you can have n number of zeros and ones, and after that also you can have n number of zeros and ones. The next one is L is equal to W does not end in BA. Does not end in BA means what are the possible endings? It can be either ending with AA or AB or BB. So therefore I'll have n number of A's and B's before, and the ending part must be either AA, AB or BB. Okay. The next one is W corresponds to the decimal encoding without leading zeros. Leading zeros means before the first non-zero number there should be no zeros. This is known as leading zeros of an odd natural number. So an odd natural number without leading zeros, an example is 1 or 13 or 217. Okay, so these are the numbers which are not having zeros in the starting part, but zeros can come in the middle, like 207. So what are the rules? The first part is 0 should not be there. Okay, first part is 0 should not be there. Then after the first digit, what can come is 0 to 9. Any digit can come, and it is an odd natural number, so the ending part should be either 1, 3, 5, 7 or 9. Okay. The next one is languages of all strings having odd number of ones. Odd number of ones means, for this I had to make the FSM. So for this question I will be explaining how to make the FSM and convert that into RE. For the next questions I will not be explaining that. Okay, so listen carefully what I am doing. The question is about odd number of ones, right? So to get odd number of ones, this is the least string, right? 1 is the least string which is having odd number of ones. So this is my final state here, and if I want more ones, I should come back here, and another time I will go here, I will get 3 ones. So this is the representation, and for zeros you will have a self loop here. Okay, so once you see the what's happening here, you are starting from 0, so you will have 0 star here. Okay, after that you are going on 1 to the final state. Okay, and there also you will have 0 star. Okay, so 1, 0 star and 1, you are coming back here, right? So this is considered as self loop, right? After you have come back here, then after that you can have n number of zeros at the end also. Okay, so something like that you will get when you draw the diagram. So this is actually the answer, 0 star union 0 star, because in the first there was a self loop here, or you can skip 0 star and go to 1, 0 star 1, means 1 from here, again 0 star was here, again you are coming back here. So that you can choose, or this you can choose, that's your wish. Okay, and this can be repeated n number of times. You can go here like this n number of times, or you can go here, or once here, or 2 times here, anything you can do. So the whole thing here is star. Okay, but the ending part should be 1, 0, because if you have to reach the final state from this state, you have to pass through 1 compulsorily, right? After that in the final state you can have n number of zeros here, so you'll get 0 star. Okay, like that for some questions are there, you have to draw the diagram, and from there you have to write the RE. Okay, so that we'll be discussing in the next topic, how to actually do that using 2 methods, heuristic and standard. Okay, the next one is languages for all strings of zeros and ones that have no pair of consecutive zeros. See, the previous one was having the at least one pair of consecutive zeros. In this there is no pair of consecutive zeros. So for this, what's the RE? How I got this RE is, if there is no consecutive zeros, what are the possibilities? It can have like 1 and ending with 0 or 1. Okay, means whenever I have a 0, it should have a 1 in the means after that and before that also. Okay, so what I can do is I can choose either 1 or 0, 1 n number of times. If I choose 0 1 n number of times, 0 1 0 1 0 1 like that, it will not have consecutive zeros. Else if I choose 1 n number of times, it will be 1 1 1 1, it will also not have any consecutive zeros. Okay, if I choose the combination of these, like 1 then 0 1 again 1 0 1, that will also not have. And if I choose this one first then this one 0 1 1 0 1 1, that will also not have. So any combination in this will not have any consecutive zeros. So this might be sufficient. But what if I want a string like 0 1 0? By just using this one I cannot get 0 1 0, but this is also a valid string, right? No consecutive zeros. So how will I get this one? At the last, what I should do is, after doing this one, like 0 1 I will write. After that it should end with either 0 or 1. Okay, if I want 0 1 1, I will be using 1 here. If I want it, if I want to end it with 0 1 0, I will be using 0 from here. Okay, so that's how you will design the RE for it, RE for this question. And the next one is a belongs to w belongs to a comma b with at most one a. At most one a means either epsilon or a, and b can be there anywhere. Okay, so b can be there in the starting part and in the ending part. Okay, and in the middle you can have a or epsilon. Okay, and the next one is it does not end with ba. So I think it was already done before. The next one is about had the substring 0 0 1. So it's very simple. Whenever the question comes like a substring question, you have to include that substring here, and in the starting part and ending part you can have 0 or more means the alphabets which are 0 and 1 here. Means what I mean is 0 union 1, any number of zeros and ones can be here and here also, and in between there should be a substring. It's not necessarily that it should be in between only, because you have 0 or more here. If you want like 1 0 0 1, the substring is ending with 0 0 1. This you can take as 0 and this you can choose as 1. So that can the same thing can be done in the beginning also, like 0 0 1 then 1. So make this as 0 and choose 1 from here, substring will be here. So both the strings are accepted. Okay. The next one is the length of w is even. If the length is even, what are the possible strings? Epsilon, length is 2, length is 4, and length is 6, and so on. So for epsilon I should have 0 or more. For 2, what I will have, 2 symbols I will have either 0 or 1 here and 0 or 1 here, and these can be repeated n number of times. 2, again if I repeat it will be 4, again if I repeat it will be 6, and so on. Okay. The next one is a power m and b power n, and m is greater than 1, n is greater than 1, and nm is greater than 3. These are the three conditions. Now tell me, if n is equal to 1 and m is equal to 1, is this a valid number or not? No, it's not, because nm should be greater than 3 and m is equal to 1, it's not greater than 3. So I cannot take n is equal to 1 and m is equal to 1. At least it should be m is equal to 1, then n will be 3. If m is 3, n will be 1. Okay. And after that you can have 2 2 also. Okay, because 2 2s are 4 and it is greater than 3. Okay, so these are the three things, and after that you can have more than 2 means anywhere. Okay, means in both m and n you can have greater than 2. Now let's design the RE for these three cases. Then after that we will have n number of m's and n's. Okay, so these are the three cases. Here you will have m is equal to 1 and n is equal to 3. M is equal to 1 means 1a will be there, and n is equal to 3 means 3b will be there. Okay, so this is one of the possibility, and after that you can have a star, means after at least 1a should be there. After that you can have n number of a's. Here also b star will be there, at least 3b should be there. After that n number of b's. Even if these two are not there, still it's a valid string. Why? Because a power 1 and this is b power 3. 3 1s are 3, it's accepted. Okay, so this is for the first one, this for the second one, and this for the third one. Okay, and these three are sufficient because any number of strings can be accepted here with the given conditions. Okay, the next one is strings of a's and b's with at least one a. At least one a means a should be there, and after that you can have n number of a's. Okay, then what is the least string? The least string is a. If the condition is accepted, then after that you can have n number of a's and b's before that and after that as well. Okay, next one is strings not ending with ab. This also done. I had done for not ending with ba. The same thing goes for here also. The point is same. Strings and strings of zeros and ones with 3 consecutive zeros. Add 3 consecutive zeros here, and here 0 union 1 star, and same thing here also. Okay, strings of a's and b's, the start and end with the same symbol. If they start and end with the same symbol, the two possibilities are a and b. You can have in between, you can have a union b. So these are the two possibilities. Next one is a power m, b power n, and m plus n is even. M and n both are odd or even. If m and n both are odd, it will be like the answer will be even number. If both are even, then also the answer will be even number. So how we make sure that both m and n are odd and both m and n are even? So for that, what we have to do is, this is for odd, this is for even. If I have a string in this case, what will be the least string here? A, B. So what is the powers? 1, 1, odd, odd. If I have if I include AA also here, at that time I will have A and B, just once I am including B. So what is the power here? M is equal to 3 and N is equal to 1. So this is also odd. So when you add up this, you will get 4, which is even. Okay. So what I did here is, the number of A's here are always odd and number of B's here also always odd. Okay. Same thing goes here also, the number of A's are even here for any number you take here, like the power, and the number of B's are also even. So here make sure even plus even will be there, and here you make sure odd plus odd will be there. Okay. The next one is all strings containing exactly one A. Exactly one A means what is the least string? Only A. After that, A should not be repeated more, so you will have B star in the starting and ending part. Next one is strings containing at least one A and one B. At least one A and one B means A and B should be there for sure. So I have an A here and B here, but it can be also the case that B appears before A. So I have B here and A here. These are two possible strings. This is one string and another string, and before A and B you can have A union B star. Next one is strings having both AA and BB as substring. So both AA and BB should be there. So AA will be here and BB will be here. It can also be the case that it's the reverse, BB comes first and then AA comes after that. Okay. And the next one is about the alternate A's and B's. So what are the possible combinations? AB, AB and so on, and B, A, B, A and so on. So it's not just these two. These two are represented here, AB star and BA star. But what if I have this case? AB and here I have B. How can I represent BAB using this one? I cannot represent. So I should add a B possibility before AB. So this is the possible combination. And same goes for the next one also. If I want ABA, how can I represent using these two? It is not possible, so I should have an A possibility before BA. So I will have this possibility here also. Okay. So these are the four strings which will be forming the union. Okay. Next one is about the strings of length less than 2. So less than 2 means what are the possible lengths? 0, 1 and 2. Right. So length 0 is epsilon, length 1 means A union B, either choose A or B. That's the only possible strings for length 1. And if the length is 2, you will have A or B here and A or B here. Okay, so it will be 2 length. So these are the questions which are important and repeated from the previous papers. So let's move on to the next one, which is FSM to RE. Okay, here two methods are there, heuristic and standard. Okay. So I'll be solving some questions which are suitable for heuristic and some questions which are suitable for standard method. Okay. The first one is the heuristic method. In here what we have is this is the FSM given to us. Okay, there are two states A and B, and A is the starting state, B is the final state. The first thing which you have to make sure is that is there any state which is dead state or not. Dead state means it cannot be reached. There are two states here A and B. Can you reach from A to B and again from B to A? If it's true, that means there is no dead state. That's the first thing which you have to check. The second thing is, in the starting state only the outgoing edge should be there. Remember this very carefully. Outgoing edge only should be there. So in A, is there any incoming edge? Outgoing is here, but incoming is also here. That should not be there. If that is there, what we will do is we will create a new state. And how we do that is like this. This is the new starting state S, and from here we have A. A will be same only. This is the diagram which was given in the question. That will be same only, but just we will have S here, which is coming to A. Now which is the starting state? This is the starting state. This has no incoming edge, right? So that's what you have to make here. And what I did here is that you should observe in the final state there should be no outgoing. Okay, there should be no outgoing edges. In A there should be no incoming edges, and in B there should be no outgoing edges, because A is the starting state, right? From starting only it will be means going out. From B means the ending state. Ending state means everything should come and end there, right? So if that two rules are not applied, that means there is a problem in the question. So you have to modify the question. So what we will do is we will create a new state, starting state as S, and then make the same diagram here. And if the final state is also violating the rule, at that time make a new final state F, make it as final state, make this as non-final state. In between you will have the same diagram. Okay. So that's what the change I have made here. As you can see, this is the new final state f, and this is the new starting state s. Okay, so after you have done that, then we'll be starting the question, starting to answer. So how we'll answer is, first we'll choose which state to remove. Either we'll remove a first or b first, it doesn't make any difference. Okay, you can remove anyone. So I'll choose to remove a first. Now observe carefully what's happening. If I remove a, I'll have a direct connection from s to b, right? I'll have a direct connection from s to b. Now to reach from s to b, which symbol I am passing from? I am passing from epsilon as well as 0. So I'll have an epsilon or 0 here. Okay, direct path to b. Now from b there is a connection to a also. So what is the connection? It's passing through 1 and coming back to 0. 1 0. It's like a self loop. If a is removed, it will be like a self loop here on 1 0. So I'll have 1 0 here. That's what I have done here. Then epsilon to f. Okay, that's what is the first state. Removing a will get this FSM here. Now after that you have to remove the next one, which is b. In the final answer you should just have s and f, and what the expression you get here, that's your answer. Okay, so if you remove b, observe what will be happening. Epsilon or 0. Okay, then you are going here, then 1 0 is there. So 1 0 is repeated n number of times. That can be represented as 1 0 star, and here you have 0. So 0 1 0 star is your answer. Okay, 0 1 0 star. Moving on to the next one, we have if this is the case, like there are multiple final states, at that time what you have to do is join all the final states into a new final state and make this as non-final state. So what we'll have is like this. The transition will be epsilon here, and f is the new final state, and these are the non-final states. Now from here you are traversing through a. So first you will get a here, then either you are going with b, c or d. So options are here. So in the bracket you will have b union c union d. Okay, b union c union d. This is what you have in the bracket, and yeah, that's pretty much it. Your answer is this much only. You will then reach to f. Okay, so a, then b union c union d. Okay, the next one is by heuristic method we will solve this one. So in this state you tell me, is there any state which we can't reach? Can we reach 1? It's the starting state. Can we reach 2? Yes. Can we reach 3? Yes. So all the states are not in dead state. So what's our next step? Our next step is to remove means check if the starting state has any incoming edge and final state has any outgoing edge. Does starting state have any incoming edge? Yes, it has. So what are we supposed to do? We are supposed to create a new s here as a new starting state, then join it with 1 and make the same diagram here. So if you make the same diagram, it will be like this. 2 will be here and a self loop, and the 3 will be here. Now 3 has no outgoing edge, so it is a valid state. So this is my new FSM. So after we get that one, it will be somewhat like this. After that, this is the valid FSM. Now we will start to remove the states. Now which state will be removing first? Observe that the state which has the self loop will be removing that first. This is not a rule, but it will be more easier. Okay, so if we remove 2 here, what is happening? See here, there will be a direct connection from 1 to 3. Okay, so suppose that 2 is removed, I will have a direct connection from 1 to 3. To reach from 1 to 3, what are the states I am passing through? B and D. So first write B, then we have in between C star also, and then D. Also I from 2 I have like B, then again I am passing AB. After B there is a possibility of AB star also. So I will have here like B, then AB star. Okay, this is the AB star here, union C star is also there. I can pass to C star also, and the whole star, and after that or else I can write like this only. I have done a bit different here, but that's all right. See here, because I missed a part here. Actually what will happen is, from here you are going B. Okay, first you write B. Okay, then while reaching 2 you are getting a self loop here for C as well as a self loop for AB. So what you will have is C or AB the whole star, and after that the final you are passing through D. So that's all what you have to write in the answer. Okay, this is all the final answer, because if you remove 2 you will get a straight path from 1 to 3, and if you remove 1 also the answer will be same only. So this is the final answer. Okay, please make the correction. Next one is about I will be using the heuristic method itself because it's a bit easier. So here what is the rule which is getting violated? This is the starting and final state. Both starting and final state are the same state. So here there should be no incoming edge. There is an incoming edge. So we should change the starting state. We'll make S, and final state should not have any outgoing. So here there is an outgoing edge. So it should change the final state as well. So we'll have F as new final state. After making the new start and final state, we'll have the diagram as follows. So here what we have, S and F on epsilon, and this is the same diagram in the question. Now remove the states. If you remove 2 here, you will get 1, you are passing through 1, then 0 star, again coming back 1, and this is repeated n number of times because you can form a self loop here. Also there is a self loop for 0. So either with this one you can form n number of times. So you will have 1 0 star 1, or you will have 0 here, which will be repeated n number of times. So that's all. What's the final answer? Because if you remove 1 also, the answer will remain same from S to F. Okay. Moving on, we have the standard method question. So in this question we will be using the standard method. Remember this formula, R of P comma Q is equal to R dash of P comma Q. I will be telling you what all it means. So for now just remember this formula, R of P and RIP, and R of RIP comma RIP star, R of RIP comma Q. Okay, so this is the this is the formula which we have. So remember this formula. Now what is the thing which we need to keep in mind? See, in this also we will have to check if the starting and the final states are valid or not. So can you tell me if this is the valid starting state? Is this valid or not? It's not valid. Why? Because it has an incoming edge here. So you have to change the starting state. What about final state? It should not have any outgoing edges. This is the final state, it has an outgoing edge. So change the final state as well. So when we make the changes will be as follows. This one. Now it is a valid FSM. Now let's use the standard method. In standard method what we have is R of P comma Q is equal to R dash P comma Q. Let's see what is this. Okay. So here what we will be doing is, if you want to reach from S to F, what are the paths? Path you will be writing first. Okay, that's your first step. Write the paths. Okay. What does path mean? From S where I am going A. So write S A, then I can go to B, then I can come to C, then again I am coming to A, then I am going to F. So this is my path. Now which letter we want to remove, we will be marking that. Suppose that I want to remove B. Okay, if I want to remove B, I will be marking B like this. Okay, and whatever letter I want to remove, that will be RIP, and the letter before it will be P. So P will be A, RIP will be B, and Q will be C. So after you have noted what is P, RIP and Q, just substitute those things in the given equation. I'll tell you how to remember this one. Just write this one, R of P comma Q. Okay, then after that write R dash of P comma Q. Okay, and you'll have a union here. Till this point you remembered, right? Then after that, what is the thing is P, RIP, Q. This is the sequence. So in the first step you will take P and RIP, that will be writing here, then RIP and RIP and star here, then RIP and Q, that will be writing in the third state. So this is the equation which will be having the union with. Okay, so let's solve a few steps, then you will get to know what it actually means. Okay, so I choose B as the RIP and A as the P, and the right part which is C will become the Q. Okay, after I got RIP, P and Q, substitute them in the formula, and now observe carefully. R of A comma C we are trying to find out. What is R dash of A and C? R dash means is there a direct path, dash means direct path. A to C, can you say me, is there any direct path or not? From C to A it is there, but from A to C it is not there. Whenever we don't get any direct path, mark it as phi. Okay, so we'll have a phi here. Then you have union, write union here, and after that let's solve this one. What are the things? AB, BB and BC. Okay, from A to B what is the path? A to B it is 1, so write here 1. From B to B what is the path? Is there any self loop? Yes, 0. Write 0 as well as star also, because in the mid part of the equation we have the RIP comma RIP star, so you'll have to write a star here. Next, B to C, that's the third part of the equation. There we'll have from B to C, if you have any transition, you'll write that transition here. It's 1, so we'll be writing here 1. So what you got? 1 0 star 1. So write 1 0 star 1 here, and while doing the union, this will be having no value, so we'll write the same answer here, 1 0 1 star 1 0 star 1. That is the answer for our A to C. Now since we have got a path from A to C, means R of A to C means what? A path from A to C. So we have got a path from A to C. Now I can remove B. So if I remove B, I can write the direct path from A to C as whatever answer I got here, which is nothing but 1 0 star 1. Okay. After I have written 1 0 star 1, remove B from the path. So if I remove B from the path, what I will get is A C A F. Next is I will choose to remove C. If I remove C, what will be RIP? RIP will be C, and what is P? P will be equal to A and Q will be equal to A. So let's solve for this one. If it's P comma Q, what is R of P comma Q? R of P comma Q will be R of A comma A. Okay, that's what we will be writing here. Next one, when we remove C, we'll be having R of A comma A, that is equal to R dash of A comma A. Then what was the sequence? P, RIP and Q. So it was A, C, A. So you'll have A to C first, then you'll have C, C star, then you'll have C to A. Okay. After writing this one, you will be substituting the values here. What is a path from A to C? Let's see the diagram. What is the path from A to C? From A to C, we got the path here from the previous answer. This is the path which we will be using. Whenever you get any path here, that will be using in the upcoming question. Okay, means in the same question in the upcoming steps, you will be using this one. Okay, so here you have 1 0 star 1. So here I will write for A to C 1 0 star 1. And what is C to C? C to C has a self loop here of 0. You will have 0 star here. Cool, you will have a 0 star here, and after that the last one is C to A. From C to A, what path you have? C to A, the path is 1. So I will write here 1. After I have written this one, do the union. In the union operation, you will keep it as such because it's not 5, it's 0. So 0 will be included. So the path from A to A is this one. Okay. Since we have got a path from A to A, we will be removing C. B and C will be removed. From A to A, there is a self loop here in the form of a self loop. If I draw in the diagram, it will be like this: epsilon and A will be here. One of the A's means this is also included, so we need not worry about that. You will have 0 union 1 0 star 1. Okay, I guess this was the answer which we got just now, and after that we have an epsilon here to F. Okay, means this path. So when we remove A, we will get the same answer here. So this is the final answer which we got here. Okay, this is the final answer which you got here, and while doing from S to F also it will not make any difference, just that you'll have R star of A comma A. So let's just solve it. This is the answer which you got till now, right? R of A to A. Now what is the path? The path is, if we remove like B and C, what we have is S A F. Okay, SAF is the path now because I have removed B and C. Now if I choose SAF, what is my RIP value? It will be A. A is RIP, S is P and F is Q. Now substituting these values in the equation, what we get is P comma Q, which is S comma F. So that's what we need to add in the final equation, R of S comma F. So this will be my final answer, whatever I get here. S means starting, F means final. The route from starting to final is the answer. So S to F, when we substitute in the equation, what we get is R of S comma F is equal to R dash of S comma F union. What was RIP? RIP was A, so write SAF here. SA first, then AA star, then AF here. Then substitute the values. S to A, what is the path? S to A, it is epsilon, as well as from A to F it is epsilon. So I'll write here S to A as epsilon, as well as A to F also epsilon. Okay, epsilons will be here, and between what we have is R star of A comma A. A comma A I got as 0 union 1 0 1 1 0 star 1 0 star 1. So do the star for this equation as well. So that's what I've written here. This equation, the same equation which we got from above, and a star for that. Okay, and epsilon will be means it will have no value, so it will be neglected. So we'll have here the final answer as this one only. Okay. Moving on, we have the next question. Here we'll have means the consideration for the dead state also. So you tell me what is the dead state in this question. In this question, you can reach from Q0 to which all strings? Q1 you can reach, Q3 also, then Q2 also. But one thing you observe, if you reach to Q3, can you come back to the final state or not? See, this is the final state, right? Q0 is the final state. So if you want to end the equation, you have to reach the final state. Can you reach the final state from Q3? No, you cannot reach. So what you are supposed to do is delete this part. So the question will be only this much. Okay, so the question will be only this much. Yeah, this one. And you have to change the starting and final state also, because the incoming edges and outgoing edges was violating the rule. So we'll have this state here, and after we get the valid FSM, start removing the states. So it's very pretty simple here. Remove the state q1. If you remove state q1, what is the value here? Passing through 0, coming back to 1. So it will be 0 1 whole star. Then you will have a union here. Here you will have 1 0 1 0 whole star. Then this whole thing is repeated n number of times. So let's keep it as such only. We'll have n number of times repetition. This is the final answer. Okay. So doing that in the same way by considering the p, r, I, p, and q values, you'll get the same answer as either 0 1 star or 1 0 star, and this can be repeated n number of times. Okay. Moving on to the next question, we have 3 states here, A, B, and C. So let's see how to solve this one. Here first means make sure that the incoming edges are not in the starting state and outgoing edges are not from the final state. Here both are violating, so we will make the new starting and the final state. Then write down the paths here. By considering the paths, which state you want to remove, you tell that first. You'll have to remove B first because it has a self loop. It will be much more simpler. So when we remove B, we'll have the A and C here. So it will when you write the paths and do it will be much more simpler. So wherever you have B, consider that. Okay. If you choose to remove this B, A to C, this P, this RIP, this Q. Substitute the formulas here. I have written here. You can go through it. After that, you will get the equation here after the substitution part, and use the equation in the next steps. Like that, you keep on doing and remove all the states until you reach S of S comma F. That's the starting and final state. When you reach this answer, what answer you get is the final answer. Okay. Moving on to the next question, let's solve this question using both methods because it's the most repeated question in the previous papers. Okay. So whichever method you feel comfortable, if they have not mentioned, you can go with that. Okay. So in the heuristic method, first is there any incoming edge to 1? No. Outgoing edge from 3? No. It's a valid state? Yes. All state we can reach. Okay. So after that check is done, you have to start removing the states. If you remove 4 here, what you can observe here? See here. If I remove 4, I'll be traversing from 1 to 2 directly. So I am traversing to B, B. So I can traverse through BB here or directly through A. So BB union A. After that, I have a B star here. So I'll have a B star after that, and compulsorily I have to pass through A. So this is my final answer. BB union A, B star A. Okay. BB union A, B star A. Solving this by the standard method, first consider what state you want to remove. If you want to remove 4, RIP will be 4. Before that, what is the path here? 1. So P will be 1 and Q will be 2. So when you remove this one, what you'll have by applying the equation, you'll get the answer as follows: A union BB. After that, what you got? 1 to 2, you got A union BB. Then from if you remove 2 here, direct path from 1 to 3. That's the final answer. 2 star you will have. So 2 star means what? This one, 1 to 2 whole star. So when you do the star operation here, you will get A union B whole star. After that, B star is here because B is getting repeated a number of times here on 2, and A is compulsory at the last. So you will get the final answer as same as heuristic method. Okay. So sometimes they mention by using FSM to regular expression using heuristic. So at that time you have to use heuristic only. So read the question carefully. Okay. So after that, what we have to do is, this is a bit different one. You have been given the table. Okay. From table you have to make this one. So how will you do that? Okay. So same which is the starting and final states. Starting state is 1 and final states are 2, which is given here as star. Okay, star means final state and the arrow means the starting state. So after making the diagram here, like you will make 3 states. After that, make the final states as 1 and 2, and after that each transition. From 1 on A, where you are going? 2. So 1 on A, 2. 1 on B, it's going nowhere, so don't make the transition. From 2 on A, you are going to 3. So 2 on A to 3. Like that, you will make the diagram, and after that, observe if the starting and the final states are violating any rule or not. So here it's violating the rule of incoming as well as outgoing. As well as there are 2 final states, we need to have just 1 final state. For that, what we will do is, we will make the new final state F here, which will be connected with the final states here on epsilon. And this is the final state and this is the non-final state. Okay, that's all what you have to do here. After doing that change, okay, after doing that change, this is the valid FSM. Change the starting state as well. Okay. So when we get the valid FSM, means remove the states here. So we have to use heuristic method. So remove that state which has the self loop. Which has the self loop here? 3, So if you remove 3, what's the thing happening here? See, how do we reach 3? From 1 2 then 3 then again 1. So from 2 to 1 I am passing through 3 also and direct path also. So I'll have a union here, either through this path or this path. Now tell me what is the equation of this path. From which all I am passing A, note down A star, note down A star, B, note down B. Union either this one or this one. Here what we have B. So union B. This is the path here from 2 to 1. Okay. So A star B union B. Removing 3 will get the same thing, A star B union B from 2 to 1. Okay. So as of now we have got this much only, like from 2 to 1 this path or this path. Now we have to remove either 1 or 2. If I remove 1, what will happen? If I remove 1, what are the changes which will be happening? See, I am coming through here, I am getting direct path to F, right? So epsilon should be included. Okay. So we'll have here like epsilon, or the next possibility is from 1 I am going to A, then I am going to F. So here I will get A, only A. So what I am getting, epsilon or A, direct epsilon or A. So I'll write epsilon on A here after removing 1. Also on 2, the thing is that once I reach through A, that is the first step, I should pass through A to reach 2. After that I am getting a self loop here, either a self loop through B or a self loop through A star B. What I mean is, see, once I reach 2 on A, I am in 2. Now I can go through B, again come back to 2. So I'll get what? B A whole star. Or what I can do is, this is compulsory, I pass through A. Okay. Either I can go with this one, or the next possibility is I can go through this one, again come back through A. So A star B, again A, then repeat this. So A star B, then again A, then repeat this one. Okay, n number of times. Also I can go through B and reach the final state, means continuously, right? Because I can come from A, then B, then I can reach the final state. That is also a possibility, right? Union B and means A is compulsorily here, so I can reach through B final state. Also I can reach directly from A star B also, right? So union A star B. Okay. And after that I can reach from A to epsilon, that's already done. So these are the possible states. After passing through 1, from 2 I can reach through all these states, and this can be repeated n number of times, means these two can be repeated n number of times. So I'll have a star on top of this, and these two are for reaching final state. So when you join all of this and simplify, you'll get the following equation. These are for the these two states are for self loop, which are the first two I brought above, and the previous means for reaching the final state either through directly through B or A star B. Okay, like this. Either through, after I reach 2, I can reach the final state like this through B. That's the first thing on in the equation I have shown, and the second thing is this one, like this. So that's the two things, this one and this one. Okay, reaching the final state, and this for the repetition purpose. Now if you remove 2, just the thing is that this is repeated n number of times, right? So you'll have A union epsilon here, and after that what you have, B A union A star B A. Okay, so B A union A star B A, and this will be repeated n number of times, and after you have done this one, then you will pass compulsorily through either B or union A star B. Either of these you can pass through. Okay. So this is the type of the question to solve using heuristic method when the question is given in the form of table. Okay, follow these steps. Okay, the next one is about the DFS shown here. We have to this same as the previous one. There is no much difference, but just that you'll have a one final state here. This is the only final state, which is Q. I guess it's okay. Q3 is the final state. Okay, so this is Q1, Q2, and Q3. Okay. So same thing, just consider if there is any dead state, then see if the starting and final states are valid states. After that, start removing the states and see what are the transitions. Based on that, make the changes. Okay. So if there are two final states, connect to a single final state. Okay. I think in the question here it was final state as well, Q2 also. So yeah, that's all about the FSM to means this was RE to FSM to RE. Yeah, this is for the FSM to RE second topic. Okay, so these are the important questions. Go through it. Okay, next one is RE to FSM. It's the reverse of what we have done now. Okay, RE to FSM means you'll be given with an equation RE, you have to convert into FSM. Okay, so 3 rules are there. The first rule is like what are the possible type of questions which can be asked in RE. Okay, first is union, second is concatenation. Okay, I'll write concat, and the third one is clean star. Okay, these are the 3 questions which can be asked: union, concatenation, and clean star. Fine. So for union, what you will do? Let me give an example. If you have like 0 plus 1, just represent this one using the FSM. Yeah. So how to represent 0 or 1? So this is the thing how you represent 0 or 1. Either you can pass through 0 or 1. So from the starting state, make a transition on epsilon. Epsilon is important. Okay, here you should have first epsilon. Okay, after that the first possibility is 0. If you come through here, you can pass through 1 and again epsilon, and then the final state. This is the FSM you have to make for union. Plus means union. Next one is 1 means the concatenation. Let's give a simple example here. Suppose that A concatenation B is there. How you will make the FSM for this regular expression? This is the starting state. Sorry, it's the concatenation, right? So both A and B should compulsorily appear. So you'll have epsilon here, then A, then again epsilon. Sorry, not like this. It will be state here, then epsilon transition. Then you'll have B. Then yeah, that's it. Okay. So A and B will appear in the same line. This for concatenation. What about clean star? Clean star means if you have like AB star. So first what you will do, you will make the same thing here. Okay, let's take A union B star. Okay, A union B star means first make A union B. This is the starting state, epsilon, and you will have A, then you will have B here, then here you have new states, and here you will have epsilon transitions on final state. This for just A union B. What about A union B whole star? Star means what? It can be repeated n number of times. Means what? Once you reach from here, again you have to repeat this one. If you have to repeat, come back here on epsilon. And clean star also includes 0 number of times. So it should accept epsilon also. I may choose not to pass through A or B as well. So at that case, include the possibility of epsilon here. Okay, that's also one thing you have to do. Just connect the final and starting state on epsilon and starting and ending state on epsilon. That's all the difference in clean star. Okay, so let's solve this question here. 0 union 1 whole star. First make 0 union 1. After that make 0 union 1 whole star by connecting this one with epsilon and this one with epsilon. After you have done this one, the next one is 1. On 1 it is getting concatenated. So concatenation means if you have one string here and one string here, just connect it via epsilon. That's all. So this the first part here 0 union 1, and for 1 what you will do, connect this one with epsilon, and here you will have 1 and again epsilon. Okay, that's all. After that in the final also you have this one. So this one will be connected with the starting state of this one. So you'll have this one connected with this one connected with this one. So if you make in the diagram will be it will be as follows. This is the first part of the question, second part and third part. Okay, the next one is also similar. Once you get the idea, you can do the same thing. Just 3 rules: union, concatenation, and clean star. Apply those rules. Okay, that's the same thing here. You can go through it. There is no need of explanation here. Okay, let's explain this one. Okay, so here what we have here 1 0 is there. Okay, or this one. So see the higher picture. In higher picture what is there? One thing is here, union with another thing. Okay, that's what's happening. So one thing and another thing. This is what I have to have in the ultimate stage, like something union something. Now in the first part something what is there, 1 0. So I'll make 1 0 concatenation. In the second part let's make it. After making this one, we'll make the answer for this one. In this one, observe carefully again. What's happening? This is one state, this is another state, this is another state. 3 states concatenated. So this is the first state, second state, and third state concatenated. Now in the each concatenation, what is happening? 0 or 1 1. So in the first stage, this is the first stage, union is happening. So make the union. That's all I know. Something union is happening with something and something. In the second part, we have 1 1. So here we'll have 1 1 concatenation. In the first part it's just 0, so we'll have just 0 here. So this part is done. Concatenate it with 0 star. 0 star means just make a transition for 0. Star means what? This is the final state of 0. Connect with the starting state of 0. and starting state of 0 connect with the final state of 0 on epsilon transition. That's done for the second one. Third one is just 1. So from here when 0 is ended, just have a transition for 1 connected with here. This bottom part was for the second part of the higher picture. The first part was this one. Connect both with the epsilon on final state. Okay, this is how you solve the questions. Rest all is the same things here. So let's move on to the next topic, which is closure properties. In closure properties, there are 8 closure properties which you have to prove. The means those are union, concatenation, clean star, and the next 3 are complement, intersection, difference, and rest 2 are reverse. Okay, reverse, and one more is there. So let's see what is the basic means technique how to solve this one. Okay, so your first step what you have to write is, if you have to prove two languages are closed under union, you have to write if L1 and L2 are 2 languages which are regular, then L1 union L2 is also regular. That's the first step what you have to write. Then after that, for L1 there is a machine M1 you have to write, and for L2 there is a machine M2 you have to write. Okay, so there is a machine M2 for L2, and construct a machine M3 that accepts either M1 or M2. So I connect the starting state of M1 with the starting state of M3, and same goes for M2 also. When you have done this one and connected the final state also, M1 accepts either M3 accepts either M1 or M2. Therefore M3 accepts either L1 or L2, that is union. So therefore the regular languages are closed under union. Same goes for concatenation as well. You will construct L1 L2, then M1 M2, then you will construct M3, which is the concatenation of M1 and M2. Therefore the languages are closed under concatenation. And the next one is clean star. In clean star there will be just one machine M1 which will have like transition, epsilon transition from the final to starting and starting to final, and this machine accepts the languages of the clean star, so therefore it's closed under transition clean star. The next one is about the complement. Complement means which languages are accepted, that are rejected, which languages are rejected, they are accepted. Okay, so that is the concept behind the complement. So you'll have a machine which will accept a language, and then you should reject all those strings that are accepted and reject all those strings that are accept all those strings which are rejected. So you'll construct a new machine M2 which does the following operation, and yeah, that's all what you have to prove in the complement. The next one is about the intersection. So intersection goes same as the previous one, where you have see, this is the intersection. In intersection the same thing you have, just as a union, just the sign will change here. And about the difference means L1 minus L2. So what languages are accepted by L1, and those will be selected, and those languages will be rejected which are accepted by L2. That's what L1 minus L2 means, right? If L1 is equal to like A B A B, okay, and L2 is equal to A. If you do L1 minus L2, you are accepting all these languages except those languages which are accepted by L2. So you will remove A here. The answer is this one. So that's what you have to explain here, and means the key points will be explained here using machine and language. Okay, so that was about the languages. And if it's a regular language, prove that the reverse of the language is also regular. So you'll have a language here, and we will have to mention 3 cases here. In the first case, E1 plus E2, so ER is equal to E1R plus E2R. L of ER is equal to L of E1R union L of E2R. Same thing goes for this one also, concatenation as well as for the clean star. For this all, when you do, you'll be proving that the languages are closed under means those are the regular languages which are closed under the reverse operation are also regular. Okay, so these are the things in the topic closure properties, and after that we have the pumping lemma. So what is the concept behind pumping lemma? The first question is state and prove the pumping lemma theorem for regular languages. So in pumping lemma what we do, we will test if the language is regular or not regular. Okay, that's the theorem. So here you have to write the following: if L is a regular language, then you have to do the following. See, one thing you can observe here, we are using a string here. Okay, that string belongs to the language. Okay, start from here, the string belongs to the language, and that string length is greater than or equal to k. K is the length of the string, and the string is represented in the form of x, y and z, where xy is less than k and y is not equal to epsilon, and q is greater than 0, such that q is means x, y power q and z. These 3 points you have to mention. That's the theorem. Okay. If there is a string that belongs to L and its length is greater than or equal to k, where k is the length of the string, and w can be represented as xyz, and xy is less than or equal to k, y is not epsilon, and q is greater than or equal to 0, where q belongs to x, y power q, z. Okay, so let's solve this by an example. Before that, a proof is there, you can go through it. The proof is nothing but we are just accepting a language here, and then it's of the length k, and it has the following form, like xy should be less than k, it must not traverse through a loop, and some key points are mentioned here which you can go. And the main point here is that it can be represented in the form of y power q z, and this should be pumped. If it's pumped and still belongs to the language, that means it's a regular language. Okay, that means it's not proof that it's not regular. Okay, so this will be more clear when you solve an example here. So these are the 3 rules which you should keep in mind. These are the second and third. This is the first rule. Okay, xy is less than or equal to k, y should not be epsilon, and q should be greater than 0, y x, y power q and z. We can choose y as we want. For example, if the question is like 0 power n and 1 power n, okay, so in that what we have to do is, we'll be using the proof by contradiction. We'll be assuming that this language is regular, and then we are going to choose x, y and z. If you will take the value of k as 2 initially. If k is equal to 2, what will be a power k, b power k? It will be a b b, right? So I am choosing x as this one, and y as this one, and z as this one. Okay, so sorry, a as x and b as y and b as z. You can choose anything. Okay, just that make sure that x into z should be less than or equal to k. Okay, so what is 2 into 1? It is 2. 2 is less than or equal to 4. Okay, that's the condition should be satisfied. After that, pump y. What is y? B. When you pump b means y power 1 is b, y power 2 is bb. So you can pump as much as you want here, and that you have to include here. If you pumped and then included, you will get a, b, b and b. This is pumped here. Now, does this language belong to the language given to us, which is a power k, b power k? Can this be represented in that form? No, it cannot be represented. If it cannot be represented, that proves that it's not regular. Same thing goes for the WWR also. Here you will have x as this one and y and z as this one. Okay. Now you will have y as something you will take in between. Now pump y and check if the language belongs to the language given to us, which is WWR. Here it does not belong to WWR, right? So it is not regular. Last one is about the P's prime number. What are the prime numbers? 2, 3, 5, 7 and 11 and so on. Okay, so let's take P is equal to 3, it will be a. So let's take this as y and pump it. When you pump it, we will get 2 a's here in between, and here we will have an a. Now this is means 2 a is here, so this does not belong to the language, which is the power of P is means power of P is 4, so 4 is not a prime, and therefore the language is not regular. Okay. Coming to module 3, these are the topics which we have to cover: CFG, CNF, ambiguity, PDA and parser in top to down and bottom to up approach. Okay, so let's get started with the first one, which is CFG. CFG means context free grammar. The first question is define CFG and write CFG to specify the following. So the questions which are present here, which will be taking one by one and answering. Okay, so the definition of CFG is as follows: a context free grammar is a formal grammar whose production rules, like we'll be writing the production rules, right? So those rules are of the form non-terminal, which means in the LHS part only a capital letter should be there, and in the RHS part both capital and small letters or the combination of both can be there. Okay, and it is represented in the form by the 4 tuples VT, PS. Okay, VT means what? Set of non-terminal symbols. T means a set of terminal symbols, which is small letters. Non-terminal means capital letters. P means set of production rules. Okay, these are the production rules which we will write, and S is the start symbol. And the first question is, all the strings are even and odd palindromes. Okay, what do you mean by even and odd palindrome? Let's take an example. AA is an even palindrome. Odd palindrome is ABA. Right. So how do we represent AA and ABA in the form of context free grammar? That's what the question is. So start from S here. You'll be understanding how to write this one when you solve some questions. Okay. So listen what I'm doing here. ASA I have written. Okay. So suppose that I want like the string AA. This is a even palindrome. So what is the value of S? It should be epsilon, right? So it will be AA accepted. So if I want, let's take a bigger palindrome. These are 3 rules for ASA, BSB, and S goes to A, B or epsilon. Let's take a palindrome like ABB, B, B, A. Okay. So this is the palindrome which I have, and what is the rules I'm going to apply? First I will apply S goes to ASA. When I apply this one, S goes to ASA, this is done. Then next is BB. So S, for S I will write BSB. Okay, in the place of S I'll write BSB, so the string is now ABSBA. Then it is again BB, so in the place of S I'll write BSB. Okay, again it will be BSB and BA. After that it is AA. So in the place of S I'll write ASA, and I'll substitute the value of S here as epsilon. Okay, so what it will become, ABBA, here it will be ABBA. That's how we will do that. Let's take odd palindrome BABA. Okay, so here first one is ASA. I'll write ASA. In the place of S, what I'll write BSB. In the place of S, what I'll write ASA, and I'm just left with B, so I'll substitute S as B, from which here. Okay, so that's how we'll solve these questions. And the next one is about a power n b power 2n. So how many a's are there? Double the number of b's should be there. For example, if the string is aa, bb, bb, how will I do how will I do that is s goes to as, b, b. In the place of s, again I will write as, b, b. In the place of s, I will write epsilon. So what is the string? aa, bb, bb, like this. Okay, so these are the two rules needed. The next one is a power n, b power n, c power m. Okay, sorry, it's n, I guess. I'm not sure about that. So yeah, a power n, b power n, and c power. Okay, it's c power m, not n. Okay, so how will you do that is we'll divide this into two parts. These are two grammars. This is one grammar x, this is one grammar y. How to represent x is, already I told you, a power n, b power n. How you will do that? A power n, b power n. First, what you will have, s goes to ASB. Here you will have ASB. So again you will substitute S as ASB. Again you will substitute as ASB. So what's happening? All A's are coming here. All B's are coming here. In the last in the middle where S is there, that will be substituted as epsilon. Okay. So what you will get? N A's and N B's. So that's done for the RHS part. Sorry, LHS part. A power n, b power n, and c power m. This is done. Okay. What about this one? Here it is c power m. How will I get c power m? I'll write y goes to cy. Why I'm writing y? Because it was two parts. X was for this one, that's over. Y is for this one. Now here what we have is y goes to cy. Again substitute y as cy. Again substitute y as cy. So what you are getting here? C, 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 and y here. How many c's you want? Write that many c's. Substitute the last y as epsilon. So the production rules needed are x goes to xy first. What is x? Axb. When x is over, you will substitute as epsilon. Same goes for y. Y goes to cy, and substitute y as epsilon. Okay, so these are the rules. Next one is about a power n, b power n plus 2. So here what we have is a s b first. So b should be n plus 2, right? If for example, a string is aa, bb, bb. Okay, so 3s and 5b's. This is the string to be accepted. What I will do first, a goes to asb, again asb, again asb. At last s should be substituted as bb. So in that way I'll get two more extra b's. Okay, asb, then s goes to last bb. In this one, number of a's should be equal to number of b's. So what we will be doing here is s goes to at, then s goes to bt. Either it can start from a or b, right? So the string can be starting from either a or b. So it should have equal number. If it is to be having equal number, at that time what I have to do is I have to here I have to make a slight difference. S goes to 80, let it be that, and these two rules are same. Okay, these two rules are same. The difference here is, let's take another letter v, and v goes to as. Okay, considering this one, make the change in the notes, and this is the rule which is the actual rule. Okay, suppose that I take like s goes to 80. Okay, I have taken s goes to 80. I should compulsorily take t goes to bs to have equal number of a's and b's, right? So actually in this way also you are not getting the right answer. So the actual grammar is this one. Okay, note it down. S goes to ASB, and after that we have S goes to BSA, and after that it is S goes to SS, and then S goes to epsilon. Okay, so this is the actual grammar which we need. Okay, and yeah, by using this one you can get the number of A's and B's as equal, because for each A I am getting a means equivalent B here, right? So if I want like AA, B, A, then I have BB. At that time the first and the last letter is A and B, so I'll write ASB. Then the middle S will be substituted as ASB, same thing ASB. Then after that I have BA, so what I'll write is instead of S I'll write BSA, so I'll have BA there, and S will be taken as epsilon. Okay, so this is the actual grammar, and make the changes. So the next one is about 0 power 2n and 1 power m. So here we will also divide the string into two parts. So here is 0 power 2n and here it is 1 power m. So it will be divided into two parts, x and y. In x we have 0 power 2n. So for each x value, means for each n value I should get 2 zeros. If n is equal to 1, I'll get 2 zeros. If n is equal to 2, I'll get 4 zeros. Like that we keep on going. Okay. So 0 power 2n and here it is 1 power m. Okay. So what we are going to do is we'll be having x here, x goes to 0 0 x. So whenever I insert the value of x, I'll get 2 zeros. And same thing goes for here also. It's just a single one, means it's just m, not 2m. So what we'll have is 1y. So each time I'll get 1y, then again y will be substituted as 1y. It will keep on going until I reach epsilon here. Next one is about 0 power I, 1 power j and 2 power k. I is equal to j or j is equal to k. So the possible strings are 0 0 1 1 and 2, or 0 1 1 1 2 2 2. So like that. Okay, means either the number of 1s and 2s should be equal, or the number of 0s and 1s should be equal. Okay. So how to solve this question is, we'll be getting two strings here. Either we'll be choosing to go with this one or this one. In the first stage we will be choosing this one or this one. Okay, then after that our grammar will be defined. So here if I'm choosing I is equal to j, at that time 0 and 1 should be like a power n and b power m, right? A power n and b power n, right? So this is the first possibility that I'm denoting as s goes to a. If I am choosing the first possibility, second possibility is s goes to b. So in the first only we are defining either we are going with a or b. Now since that is defined, the question is simpler. 0 power means if I is equal to j, it will be of the form 0 power n, 1 power n, and here it will be 2 power m. So how to solve this one? Divide this into two parts, take it as v and w or some letter here. And how to solve this one I have already discussed. It will be like 0 v1 and v goes to epsilon. Okay, so 0 v1 will make sure that it will be equal number of zeros here and and equal number of ones here, and v will be finally epsilon. So I'll get 0 power n, 1 power n here. Next is 2 power m. That's pretty simple. W goes to 2w. How many w's, how many 2's I want, I'll write. After that I'll substitute as w as z, means epsilon. That's what I've written here. A goes to vw. V is for 0 power n, 1 power n, and w is for 2 power m. So I've written here 0 v1, v goes to 0 v1, and when it's over v goes to epsilon. W goes to 2w. How many 2's are there? That many we need. Finally we'll write the value of w as epsilon. So that will also be over. Then s goes to b. What does b mean? B is nothing but 0 power m, 1 power n, 2 power n. So first we need 0 power m. So for that we will be taking a letter. For example, what I have taken is z, not z. I have taken here as x. Okay. So x is equal to how I should represent 0 power m. That will be nothing but x goes to 0x. It will keep on going until x reaches epsilon. So that's over for the first part. The next part was 1 power n, 2 power n. Okay, this one. I and j and k value should be equal. That means it's of this form. In this form I am taking the y representation. This represents y. How will we define y is y goes to 1y2. Again y will be substituted as 1y2, and it keeps on going until number of 1s and 2s, means it will be equal in each stage. When it's when the string is over, I will substitute the value of y as epsilon. So y is substituted as epsilon at the end. Okay, so these are the things which you have to define for this question. Next one is a power n, b power m, c a power n. Okay, here a power n and a power n are same. So what I'll be doing is I'll be taking this as a sa. Okay, a sa. How many times I want like a's, that many time I'll substitute s as a sa. When it's over, I'll substitute the s value as bt. Bt, why? Because I need b power m. So what will happen is, suppose that I want like a ba. Let's consider for this one. First is what? A. So I'll use this one, ASA. Then S is this one. I'll substitute again ASA. Then I want just one B. So I'll not substitute ASA. I'll substitute S is equal to BT. So S is equal to BT, and just one B is needed. So I'll substitute as epsilon. Suppose that there were 3 or 4 B's. At that time what I will do? T will be written as BT again, and BT again. After that it will be substituted as epsilon at the end. Okay. The next one is a power n and b power n. It's pretty simple. A as b and s goes to epsilon. A power m and b power n. Here a power m means n number of m, and it's not equal. Okay, that's very important. So here what we will be doing is, if it's not equal, what are the possible strings? AAB or ABB or triple B also. So let's see how to solve this one and this one. A as b. Okay, A as b, what we will do? First it will have equal number of a's and b's. Okay. how many times I do A S B. If I put this as epsilon, at that time number of A's and B's are equal. How to make it unequal is that I have to just write here S as B. If I write here as B, at that time the number of B's will be different. If I write here as A, at that time it will be different. Means if I substitute S value as A, the number of A's and B's will be different. So that's just one of the possibility, but we can have n number of A's also in the middle, right? That possibility also exists. So what we can do is we can make a change here. S goes to AT and S goes to B U. Okay, BU we can take. So what will happen is AT will be there. How many A's we want, we can substitute at that place. So that will cover. No, it might become equal number. That's also there, right? So yeah, that's it. What I have written here, that's sufficient. So let's move on to the next one, which is X, UI, VI and Z. Here you can divide in two parts, this one part and this one part. Okay, so first what will happen, only one X and one Z is needed. So S goes to X, T, Z. Then we will define T. What is T? U power n, V power n, in the same form, right? So here what we'll do, T goes to U power n, V power U power n, T, V power n. T will be written again as UTV, again UTV and so on. How many U's are there, that many V's will be there. Finally T will be substituted as epsilon. For WWR, one thing you have to remember, it's palindrome. Palindrome means what? Let's take a palindrome here. This is a palindrome. First and last letter is same. Second last and the second letter is same, and the final letter is also same. Okay. So sorry, it's this is one odd palindrome. We need even palindrome. So in even, what will happen? How many letters are here? That many letters will be here also. So it is A, S, A. Then S will be written as B, S, B or A, S, and so on. Okay, S will be substituted as epsilon in the end. The next question is A power n, B power n, C power m and D power m. Okay, so here what's the thing is, we will be dividing this into two parts, X and Y, and we'll be solving X and Y separately as we have done before also. So X will be A, X, B and Y will be C, Y, D, and we can substitute epsilon also. The next one is A power n and B power n, and here we have WWR. So this will be taken as separate. So here what we have is A, X, B, and n number of A's and B should be in the starting and ending. So we have here A, X, B. So X can be substituted as A, Y, A and B, Y, B also. So why we need that is for the palindrome. The upper part is A, X, B, and here we'll have for the palindromes, as I have told, starting and ending should be same. So it will be A, Y, A or B, Y, B, and Y will be defined as A, Y, A or B, Y, B, and it can be substituted finally as epsilon. Okay. Next one is A power m, B power n and C power m plus n. Okay, so here we'll have two parts. First, two parts. So here we'll just have A, M, and means how many number of A's are there, that many number of C should be there. In along with that, how many number of B's are there, that also should have equal number of C's. So first we will make a number of A's. How many are there in C's? So A, X, C. So we'll have A, then we'll have C, 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 and here we'll have X. Then what we need, we need B's here and equal number of C's also here. So what we'll be doing is, we'll be doing B, Y, C. Okay, X will be written as B, Y, C. So it will be B, Y, C, again B, Y, C, and so on. So the number of C's will be equal to B's here, and number of C's here will be equal to A's. So the total when this string continues, the total number will be equal to the total number of A's plus total number of B's. Okay. The next one is A power m, B power m and C power n. Divide into two parts and do that separately. We have done this earlier also. This also same WWR. For the palindrome, you will have A as A and B as B, and S will be written as C at the end. Then the next topic is Chomsky's normal form. Define Chomsky normal form. Context-free grammar is said to be in Chomsky normal form if all of its productions rules are of the form A goes to BC, means two capital letters. These are the non-terminals, means all the productions which you write here, like S goes to something, A goes to something, all those should be in the form non-terminal goes to two of the non-terminal, and one of the non-terminal goes to terminal, and S goes to epsilon. Okay, S is nothing but the starting state, that should go to epsilon, that also should be there. Okay, and the first question is S goes to AACA, and A goes to this one, B and C. So what are our steps? Okay, so first I have written the steps here. Remember these steps. Remove the useless and unreachable states. So any useless and unreachable states you can find here. Which are those states which are useless or unreachable? Those states are useless or unreachable if by any of these productions I cannot reach this state. I'm starting from S. I got A and C. From A and C, I got C here, and from B, from A I got B, and from B I got C. So ABC is only reachable. D and F are not reachable. So cut this off. That's the first step. Second is remove the epsilon productions, which we'll be discussing now. After that, remove the unit productions, and finally remove the mixed symbols. So all the productions finally should be of the type this one or this one. If it's not of that type, we'll be doing some technique. Okay, that technique is included in the topic. Remove the mixed symbols. Okay, what is our first step? Remove the useless variables and unreachable states. And my means what I analyzed is that there is no variables which are unreachable. So therefore, all the variables are reachable. That's the step one. Second step is remove the epsilon productions. Which are the epsilon productions you can find here? Where you can find epsilon? Here, C goes to epsilon. This is the epsilon production. So you have found this one. What you have to do is substitute all the places where you can find C as epsilon. Where all you can find C? Here, here, and here. When you substitute all these places as epsilon, what you will get is this one. Keep the first string as same. Then after that, when you substitute epsilon, write what it is. Here also substitute epsilon and write, means it will be epsilon only, so no use. So here when you substitute epsilon and write, it will be C here. Before it was epsilon, instead of that it will be C here. So that's our first step, remove the epsilon productions. Then the third step is remove the unit productions. What are the unit productions? One example is this one. A goes to B, B goes to C. Non-terminal to a single non-terminal, that is the unit production. So how can I remove that one? So start from B, and in place of B to C, substitute C goes to C, C and C. So what is B here? What I mean is, instead of writing A goes to B, again B goes to C, I can directly write A goes to C. I mean, instead of B, what is the value that I can write directly here, right? So what I will get, A goes to this one instead of B, C, C. This is from the previous one, A. So I got this value here. Like this I have to write, okay, in all the productions. So A goes to this one, I will write here as such. And what is the thing is that A also goes to epsilon. In the epsilon productions, you have to remember one more thing. C goes to epsilon, what we did? All the places of C we substituted as epsilon, right? So but one more possibility is there. A goes to B, B goes to C. So when C goes to epsilon, obviously B goes to epsilon. So B goes to epsilon means A also goes to epsilon. So wherever I find A also, that also I have to substitute as epsilon. So here 4 possibilities will be there. One of the possibilities A epsilon, the first one I have written is C is going to epsilon. Second possibility is only A is going to epsilon. So it will be ACA. Then both A and C are going to epsilon. So it will be AA just. Like that we have to see all the possibilities and make. Okay. And talking about the unit productions, we have done that one, and the final answer will be this one. This is because of epsilon production, this is because of unit production, and this is as such. Now our last step is remove the mixed symbols. What is mixed symbols? I have told you earlier. A goes to 2A, means it should be of this form or this form, either one terminal or two non-terminal. Consider the first one. Here you can see one terminal, two non-terminal, one more terminal. This is the invalid state. To convert this, we have to change first into all non-terminals. These terminals are here, right? This should be converted to non-terminals. How can we convert that? Instead of small a, I will write capital TA, and then I will define what is capital TA as T goes to A. So this is valid non-terminal to single terminal. This is valid state, and this also has converted to capital TA. Here also write capital TA. So all are of the form capital letters. After you have made all the letters as capital letters, what you have to do is this one. See, this is the string which we have, right? TAACTA. Now this should be of the form two capital letters, means two non-terminals. To convert this into two non-terminals, I'll take the first letter, I'll write here, and the rest of the string I'll write as S1. So it is of the form two non-terminals. What is S1? S1 is A into S2. What is S2? CTA, two non-terminals, so I'll keep it as such. Same thing do for this one also, and this one also. Wherever you find small non-terminal, make this as capital. Wherever you find small terminal, make this as capital non-terminal. For example, small c is here. Write it as TC, and then define TC as TC goes to C. Like that when you do for all the strings, some will be repeated also. So you can take the same string. For example, in the last one you can see here s goes to CTA. CTA is already defined in S2 while we are solving the first one. So we can just write here S2 instead of another like S4 or S5. That will reduce the states. Okay. So that's your final answer. After you have written all these, your final answer will look like this. This is the final answer. Okay. Same thing we'll do for this also. First check if all the states are reachable. Yes, it's reachable. There is no epsilon production, and focusing on the unit productions. What are the unit production you can find here? X goes to A goes to B, Y goes to T goes to Y. 4 unit productions are there. So instead of X goes to A and X goes to B, X goes to A, then X goes to B, A goes to B, I can directly write X goes to this one, and instead of B I can write small b. So what I will obtain is the same thing I have written here, and after doing that I will get this one. S goes to X goes to A or B, and for Y also Y goes to T and T goes to Y or C. So finally T is going to C. So instead of Y I can write here as C. So Y goes to C I will be writing here. Okay, Y goes to C. So this is my final state. S will be remaining as such. This is the valid state. S goes to XY. So S will be there as such. S goes to XY. Then X goes to A or B. Y goes to C. This is the finalized form. Okay. So these are the two main questions in the topic Chomsky normal form. There are few more questions, but these are two most repeated ones. Okay. And next one is the ambiguity. So what is ambiguity? What is LMD first of all? LMD means a leftmost derivation is obtained by applying production to the leftmost variable in each step. Okay. So leftmost variable is which one in this case? E. So this will be written as so see, these are the rules given to me. By using this I have to form LMD. Okay. To form LMD, what I will do, I'll substitute this variable as E star E. Then from here I'll start ID, then I'll go to this one, I'll substitute ID, then I'll go to this one, I'll substitute ID. It will be ID star ID plus ID. That's the leftmost derivation. In rightmost derivation I'll start from the right and I'll move towards the left. So first this E will be written as E star E, then here it will be ID, then this one ID, then this one ID. Okay. So from right if you do it's rightmost derivation, if from left you do it will be leftmost derivation. What is a parse tree? A parse tree is a derivation tree which has which is ordered, and it represents the syntactic structure of a string according to the context free grammar. Okay. So the parse tree for ID plus ID star ID is this one. So it's as the previous one. First you did E plus E was written as ID for the leftmost derivation. E is E star E, then E was written as ID. So the final string will be the leaf nodes, which is the leaf nodes E plus ID into ID. Okay. What is ambiguous grammar? It is a context free grammar for which there exists a string that can have more than one LMD or RMD. If for the same string there exists more than one LMD or RMD, it is a ambiguous grammar. It's a very important question, so listen carefully. The W is given as IBT, AEA. Okay. So what I have to find out is I have to find out two LMDs using different rules. Means applying the rules in different order, I am getting the same answer. So how is that possible? See here. It is given IBT, then IBT AEA. So first what I will do in the first LMD, I will take S goes to ICTS. After that ICTS, S will be written as B and S will be written as this one. Okay, C will be written as B and S will be written as ICTSES. Then for S I will be writing as A, and for C I will be writing as B. So finally what I got, IBT from the first S, and from this IBT I got from ICT first, and this one I got from ICTSES. Okay, this was the first way. In the second way what I am doing, firstly only I am taking ICTSES. Okay, in the first step I am taking this one for the second second LMD. In the first LMD I took this as first, right? So the order is becoming different. Let's see if we get the same answer or not. So when I take this one, I'll write it as same. Then this L for this S I'll write as ICTS. So I'll write ICTS. ES is from previous one, and this will be written as IBT. When you substitute C as B, this will also be written as IBT. Then SES will be written as AEA. Did I get the same answer in the end? If I got the same answer using two different LMDs, that means it's the ambiguous grammar. Okay. Next one is this one. This is also very repeated question. So you have to find LMD, RMD and parse trees. Okay. So ID plus ID star ID. You have to do the LMD. LMD means start from the left. If you have to start from the left, you have to substitute the left part. What you want finally? Plus ID and star ID. So when you take the value as E star E, if you start from left, then you can substitute as E plus E, then star E will be here. So this will be coming first, right? So first you have to start from E star E. Take the rule which is E goes to E star E first. After that E plus E, then start substituting ID from here. You'll get the answer ID plus ID star ID. Now suppose that you have to do RMD. In RMD, if you want E plus E star E, where you have to start from? You have to start from here. Okay, first you will have E plus E, this will not be there. This E will be written as E star E, so you will get the same answer again. So in RMD you have to start from E plus E, and in LMD you have to start from E star E. Then this will be written as E plus E, so that you get the same answer at the end. Okay, so that's what you have done here, and ID will be substituted from the right side and till you get the final answer. Past trees means you will be doing the same thing. What is the first rule here? E star E was written, then E was written as E plus E, and then ID, here also ID. Same thing here also. First E plus E was written, then this one was written as E star E, then ID, and here also ID. This string is same at the end. Okay, so let's consider the string AA, BB, A, BB, AB. So for this we have to, these are the rules given. You have to find two LMDs. Okay, so what we'll be doing first is this question you'll just get to know by practice. Okay, because finding out the sequence from your own is very hard. Okay, so listen this question. If it comes in exam, you can write. Okay, so S goes to AB and BA. So these are the rules which are given to us. So how we'll approach is, first you see here, it is starting from at the end I am getting B. If in the we have to start from A, we will start from here itself. First letter is A. So S goes to which one I have to take, this one or this one? First I will take this one, right? Because then only I will get the string which is starting from A, AB. Okay, so I will write here as AB. Then I will substitute B as see, I'm in B now, right? After I've written S goes to AB, I'm in B now. So what is my next letter? A. So what is the obvious thing, string I have to select? This one, ABB. So I'll write here B goes to ABB. Then for the next B, what I have to do? The next letter is also A, so I'll write ABB again. So I'll have ABB from the first B, and the second B will be written here itself. Okay, after this point, what is my next string? It is the next letter is B, so I have to select BB. Okay, I can either select BS or I can select B. So what I'm doing is, in the first string I'm just writing here B. Okay, then the BB is from the previous one itself. So after that I'm writing BS. Okay, after that I've written here BS, then S goes to A, B, and this B is from here, then B goes to B, then this B goes to BS, then S goes to AB, then B goes to B. So the difference what happens in second LMD is that till this point I will come as same A 3 times, then instead of just substituting B just as B here for this one, what I am doing is, here I am doing as BS. The first B is written as BS. Okay, so there is a difference here. I am taking B here, but I am taking BS here. Then follow these steps here, you will get the same answer. Okay, just as I have how I have written here. If you follow these steps, I am getting the same answer. Okay, so there are two LMDs, therefore the means the grammar is ambiguous. Okay, the next one is this question. Here also it's a pretty simple one. You just have to generate the LMD and RMD, so you can go to this one. And here also you have to generate two LMDs and RMDs. So what I did is, first I took SS, here also SS. Then first S is written as S in the bracket, and second S is written as just one S. Means I have substituted epsilon for this one. When I have one S here, then I can write it as in the bracket S, then this can be written as epsilon. Here what I did, this one was taken as epsilon here, so it will be bracket means empty bracket, and this S was taken as epsilon, so I'm getting in the final state only brackets. Okay, so it has two LMDs, therefore the grammar is ambiguous. Okay, here also you have to do the two LMDs for proving it as wrong. You can go through it. It's a pretty simple one, and here it is AA, so you can go AS first, then AS, then X goes to A, and AX first you can go to S. From S you can go to X, and X goes to AX, and here also you can write it as S. Okay, and finally you will substitute A as the final string. Before that, substitute AX here. Okay, for each stage. So this has two LMDs, therefore the grammar is ambiguous. Okay, coming to pushdown automata, I have made the videos, so that will be played now. Coming to pushdown automata, the first question is L is equal to A power n and B power n. Okay, So how do you solve in push down automata is that first we'll have a stack. Okay, in the stack what we'll be doing is we'll be storing the alphabets here. So we have the alphabets A and B. So on each it means whenever I encounter an A, we'll be storing an A here, and we'll keep on doing that until we encounter B. When we encounter B, we'll be cutting here, cutting the A from here, and when we reach the end of the stack, we'll be stopping. Okay, so that's how the push down automata works. For that, let's first write down the transition function. Okay. So the first transition function is, first you will write like this is the starting state q naught, and epsilon is the input, means what is the input you will write here, and next one is what is the top of stack. Initially top of stack will be empty, so it will be z naught. Okay, and you will be writing here what is the transition it's going to. It is going to which state? It's going to the same state only, means there is no input, it will stay in the same state. And what is the content of the stack, means top two elements, that is just z naught is there, so I'll write here z naught. That is the first transition function. Okay, next transition function is delta on q naught. I can means the first alphabet which I am encountering is A, so I am getting the input as A, and the top of the stack is z naught. So at that state what I will do, I will stay in the same state q naught itself, and I will accept the A here, so it will be A z naught. What if another A comes? If another A comes, at that time the top of the stack will be A, right? First it was z naught, A came, now the top of the stack will be A here, so I will write here A and another A here, so it will be q naught, and what is the top two elements of the stack? A. That is for A on A. And what happens is when we get a B, what we should do is we should pop an A, right? So whenever we encounter B on top of A, at that time what we will do, we will pop it. Pop means I'll go to the next state here q1, and this epsilon means pop. Okay, so that was for B on A. And whenever we in q1 whenever I encounter more A's, means suppose that there are 3 A's here, then if I encounter B, one will be cut, another B, another A will be cut, and so on till I reach z naught. So for that I have to define from q1, if I encounter a B on top of A, at that time I have to cut it, so q1 comma epsilon. So this will happen until I reach z naught. So when I reach z naught, my input is 0. Okay, means my the string has ended. At that time my state will be q1, at that time no input is there, and I am on z naught. If this is the case, that means the number of A's and B's are equal, and I'll reach the final state. Okay, let's define q2 as the final state, and I'll have the top of the stack as z naught. Okay, so this is the transition function which you have to make for this question, and its n is greater than or equal to 0, right? So from the starting state itself you have to reach the final state also. So from here you will have this one as well as q2 comma z naught. Okay, means if you have the epsilon input also on z naught, still you have to reach the final state. That possibility is also there. So let's make the transition diagram for this. Three things we have to make. First is the transition functions we have to write, then we have to make the transition diagram. After that, instantaneous descriptor for any sample string. Okay, so let's see how to draw the transition diagram. What is the starting state? Q naught. So just make q naught as like you had made before. After that, what is the inputs you have? The inputs can be A on z naught, and yeah, just A on z naught, right, and epsilon on z naught. So two inputs are there. If it is A on z naught, I will stay in the same state. If I get A, the input, and the top of the stack is z naught, the content of the stack is A z naught. Three things you are writing: what is the input here, what is the top of stack, and what is the content of stack. Okay, after I have written this one, whenever I encounter a B, at that time I will means B on top of A, I will pop it and move to the next state q1. In q1 I will do the same thing, B comma A epsilon. So until when I have to, until my string gets over. String gets over means here in the input side it will be epsilon, and the top of the stack should be z naught, because the string is over means z naught is remaining, and the top of the stack will be z naught itself. So if I encounter this case, that means number of A's are equal to number of B's, so I will reach the final state q2. And from here only, if I get an epsilon transition, that means the string is empty. That also should be accepted. So epsilon comma z naught and z naught. So this is the transition diagram for the given question, and let's consider a sample string here. So let's consider you have to write q naught first, which state you are starting from. Then you have to write comma. Then let's consider a b b b. and after that you will have the content of the stack. Now q naught on a, which state I am going? Same state only, q naught, and a will be cut from here, it will be a b b b, and it will be joined here, so a z naught. After that I'll stay in the same state for the next a also, so it will be a b b b, and here I'll have a z naught. Another a, it will be the same thing, you'll have 3b here and 3a and z naught. Now I'm encountering a b. Whenever I encounter b, I am changing my state to q1, and two b's are here, and this b will pop the first a here, means the latest a. So I'll have 2a here and z naught. After that the same thing goes for the rest two also, so I'm skipping that for now. So I'll reach the I'll stay in the q1 itself, and I'll be reaching the epsilon here. 2 b's will cancel these both, I'll be remaining with z naught. So when I reach this case, like q1 and epsilon and z naught, what I had written here is the same thing, q1 epsilon and z naught, I'll reach q2 comma z naught. So I'll reach from here, that is equal to, like this I'll write, then after that q2 comma z naught. Okay, so this is the final state. Okay, this was for the first question, which is L is equal to a power n b power n, where n is greater than or equal to 0. If it is 1, you will just have remove this one. Okay, that's the only difference. So that was for the first one. Let's move on to the next one. In the next one we have L is equal to a power n and b power 2n. This is the second one. L is equal to a power n b power 2n, and here also n is greater than or equal to 0. Okay, for this one let's start. What will be the approach is, whenever we encounter an a, I'll be inputting 2a. Okay, what I mean is, suppose that the string I got a b b. Okay, if n is equal to 1, at that time I should get this input. But if n is equal to 1, my the input in this case it will be like a b b. But how will the stack know that for one a I have to cut 2 b's? So what I will do is, whenever I encounter one a in the stack, what I will do, suppose that this is the stack, z naught is here. So I have encountered one a, at that time I will input 2 a's. I'll input this a, I'll copy this again, so I'll get 2 a's. Next my input is b. For each b I'll cut one a, another b I'll cut another a. So what happens is, for each of the a I am getting 2 b's here, means corresponding b's, right? Because 2a I am writing, that will correspond to 2 b's. That's the approach of this question. Let's start with the transition function. In the transition function, what will be our first function? Delta of q naught comma epsilon on z naught, that is equal to q naught comma z naught. Okay, this is the first thing which you have to write, and after that the next one is q naught on the first thing which I encounter is a, and the top of the stack is z naught. At that time, instead of getting just one a, I'll write 2a z naught. For each input of a, I am writing here 2 a's. Okay. The transition function for a on top of a is q naught comma a on a. At that time, the output what we will get is q naught comma a and another a. This is the top of the stack, and I am inserting 2 a's. Okay, so that's why I have written 3 a's, just as the previous one. So what will happen is, each time one a is inserted, I'll insert 2 a's. So for that 2n will be satisfied. Okay. Now let's define for b. When I encounter b, like q naught comma b on a, at that time which state I will go? q1, and I will be doing the epsilon. Okay, and the same thing will be done in q1 state as well, like b on a, it will be q1 comma epsilon. So that will be done until I finish all the a's. How many a's are there, that many b's will be cut, and after that the last one is q1. I haven't said q1, there is no more input here, so epsilon and z naught. So I'll get here as q2, which is the final state, and here I'll have the top of the stack z naught. So this is what the transition function for this question. So let's make the diagram here. So in the transition diagram, what we have is it's starting from q naught, and the input which I am getting is a on means z naught, a z naught, sorry, not a z naught, it will be a z naught, and on top of a I'll get as double a, and when I get as b, at that time what am I supposed to do? B on a is epsilon, and it will reach q1. It has a self loop here which is b on a is epsilon, and when it gets over, like the input is epsilon and the top of the stack is z0, and the content of the stack is also z0, so it will reach the final state q2. And it's since it's n is greater than or equal to 0, I'll have here the direct transition on epsilon comma z0 is z0. Okay, so this is the transition diagram, and id you can make by yourself just as the previous question. Okay. So this was the second question. L is equal to a power n and b power 2n. So let's see what is the third question and try to solve it. So the third question is about the palindrome. So let me write the question here. L is equal to wc wr. Okay. So in this what we will be doing is we'll be having w as the strings a and b, and the reverse of it will be here. So let me give you a brief overview of how this question is going to be solved. Okay. So in this question, first let's consider a stack here which has the z0 here, and let me consider a string w as abb. Okay, abb. So first a will come here, I'll take it in, and b will come here, then b will come here. After that c is coming, so I'll write here as c. I'll not do anything. Actually I'll not write c, I'll just indicate that c will be as like an indication of that this thing is over and the reverse is starting. So I'll not include c here. Then after that it's wr. What is the reverse of this one? It is bba. So one thing you can observe, the last one will be cut with the first one, b will be cut with b. So if I encounter the same letter here, that means it's a valid palindrome. For the next letter with this letter, if it's same I'll cut. Then for this letter with this letter, if it's same I'll cut. So in the first stage I'll just accept the letters and store in the stack. When I encounter c, I'll change the state, and after that if I get the same letters in the order, means while cutting, if I get the same letters, that at that time what does that mean? It means that it's a means in the form of w and wr. So when when the input is over, at that time I will reach the final state. So let's write the transition function. In the transition function, the first function is delta on q0 comma epsilon and z0. So this will lead me to the state q0 comma z0. This is the starting one, and after that we have the possibilities of both a and b. Okay, so let's write that. If it is a on z0, I'll just accept it, I'll stay in the same state, I'll write a z0. What if it's b? At that time I'll have q0 comma b comma z0. So I'll have here q0 comma b z0. What if it's like a on b, or a on a, then b on a, b on b? Those four states also I should define. So let me write down that one, b on b. So if it is b on b, it will be the same thing, q0 comma b on b. I'm just accepting all the states. Okay, whenever I encounter any more new states, I'll accept it unless and until it is c. Okay, so let me write down here, a on a will also be q0 comma a. Then what if it's like a b and b a? So let me write down that as well. So it will be q0 comma a on b, it will be q0 and a b. After that the last one is q0 on ba. It will be same q0 comma ba. So I have defined for like all the possible combinations, either it's starting from a or b and it's encountering b on b, or a on a, or a on b and b or a. Okay, so after we have defined this one, if it encounters c, that means the string is over. At that time what is the transition function is, what is the letter I am encountering, which state I am, q0. What is the letter I am encountering, c. C on top of what, either a or b, both I have to write. Okay, so let's make two states here, either a or b, I'll encounter c, right? So here what I'll write is which state I'm going, I'll change the state here. Okay, q1 comma I'm not taking any input, so the top of the stack will be same only. I'll not write c here. Okay, so after that I'll write here q1 comma b. If it's b, I'll write b. If it's a, I'll write a. It's just an indication for the change of state. And after that when I reach the reverse state, at that time what I told you earlier, I have to get the same letters in the sequence. So whatever is my input left, that should be the same order of the stack here. Okay, so in the 10th transition function, what I'll have, I am in state q1. If I encounter a b on top of b, at that time only I will pop it. And the next possibility remains is q1 comma a comma a. if I'm getting an a on top of a, that is the correct sequence, I'll be popping it. Other than that, it's a wrong sequence, I'll not define any function for it. So this is all what you have to do, and when the string gets over like q1 comma, there is no input left and the top of stack is z0, that means it's a valid string, I'll reach to the final state q2 comma z0. Okay, so this is the transition function. Let's make the transition diagram. Okay, in the transition diagram, how we'll start is first as usual q0, and in q0 I can either get a or b, so both I have to define the possibilities. A on z0 I'm getting a z0, b on z0 I'm getting b z0. What if it's aa or bb? Same thing, aa will be aa and bb will be bb. What if it's ab? It will be ab. If it's ba, it will be ba. After you have defined this one, what if you get c? C on top of what? Either a or b. Okay, so here we'll keep the state as same only, like a and b, and we'll reach to the state q1, and here we'll define two things. If you get b on top of b, cut it, means pop it. If you get a on top of a, pop it. Then when the string is over, you'll get no input here, epsilon on z0, the top of the stack, and the content is stack z0. So when you get this state, you'll reach the final state here, qf. Okay, and if you get directly c from here, that's also the valid state. Like the w is empty, so at that time c comma the top of stack is z0, at that time you will not insert c, you will keep it as z0 itself, is the final state here. Okay. So this was for the question which is L is equal to w c w power r. Okay, so the next question which we have is slightly different than this one, which is wwr. Okay, so let's discuss that one. It is not like similar one, but it has a slight difference. Okay, so let's see how to solve that one. In wwr, you will have the strings which are even length, right? Let me give you an example for wwr. This is the fourth question, and L is equal to wwr. Okay, so whatever length of w you take, that same length will be wr. So when you add up the same numbers, you will get the even length, isn't it? So let's take w as a b b a. wr will be the same thing, a b b a, the reverse of it. Length is even here. One thing you can observe, when I get the same letter, at that time only I can say that the string is changing. The string cannot change on different letters, means w and wr, the last letter of this one and first letter of this one cannot be different, it will be always same only. Why? Because ab, the next part of the reverse string will be the reverse of it, it will starting from reverse of it. What is reverse of it? ba. So this same letter is getting the first letter here, the last letter of this one is first letter of this one, so these both will be same in the equation. So that's what the point you have to keep in mind. So when we create a stack here, this is the stack here z0, suppose that a b, after that if you get another b, you will cut this one, and then a, you will cut this one, but we are still not sure of it, right? What if the string is a b b a and another time a b b a? What if I just did like a then b, another b came, so I thought that this is just the string here, it will cut and this will also cut. After that some things are remaining, but I have not defined for that one, so I am not sure that it will be the same case. So I have two cases here, either I'll go with this one, or I'll consider this as the part of another string, the next repeated letter will be considered. So this will be cut from here, then b will be cut from here, then this b will be cut from here, then this a will be cut from here. So this is the correct answer. So I'll try out both cases, whichever I get answer, I'll consider that. Okay, so that's what we will do in each step. Let's write the transition function. What is the first transition function? The first one is delta q0 on epsilon, and the top of the stack is z0, so it will be q0 and z0. Okay, so this is the first equation which you have to write. The next one is about what I'm encountering, either a or b. So q0 comma a on z0, so it will be q0 a z0. The next one is q0 comma b z0. The same thing as you have mentioned earlier, means did in the previous question, the same thing we have to write here, q naught comma a on a. Yeah, the difference what's happening is, let's write down for the different letters. AB, it will be q naught comma AB, q naught comma BA will be q naught comma BA. Till this point I hope you understood. We have just written as the previous one. Now the difference comes here, q naught comma AA. AA can be either the means the string has not ended, W has not ended, and this is the part before W ends. It can be means same letter, means it is part of string or in the middle part, both can be possible. Let me give a better example here, ABBA and ABBA. If I get same letters, it might be a part of the string. This W, it might be a part of string, or I can even consider that as the means the separation part between W and WR. Both are the possible combinations. Okay, I am not sure of it which one it is, so I'll consider both the possibilities. First possibility, it is a part of string. If it is a part of string, I'll just accept it like AA, like this one. I have accepted BB and I'll move forward. Or if it is this one, I have to start popping. I'll move to new state Q1, I'll pop it. A with A will be popped, then B with B, and so on. So both possibilities are here. Same thing goes for B also. Let's write down that quickly. BB, Q0 and BB will be here, or it will be moving to Q1 and popping it. Both possibilities exist. Okay. So in case we reached Q1, so before that, let's see, we have defined all the functions for this one or not. Epsilon z0, a z0, b z0, a on b, b on a on a, b on b. For Q0, all the states are defined. Let's move to Q1 now. Suppose that I reached Q1. In Q1, I'll encounter what I'll cut is just the same letters, a on a. Right. Q1 means what? It has reached the separation part, and I am now cutting the same letter with the same letters, because which state I am in? The reverse state. Okay, so I'll just define for the same letters to cut. Okay, Q1 comma epsilon, and here the same thing goes for B as well. Q1 comma B, it will be Q1 comma epsilon. Okay, this much is done, and when we will come out of the state, when we will get when we will be means having no more inputs, so it will be epsilon, and the top of the stack is z0, and it will be Q2 comma z0. Okay, Q2 comma z0 will be there. So this is the end of the string. This is the final state. So let's see how to draw the transition diagram for it. Considering the transition diagram, which is the starting state, this is the Q0 state. In Q0 state, I can encounter both A first or B first, both on Z0, so it will be A Z0 and B Z0. What if there is already letters like A on B, it will be AB, B on A, it will be BA, and A on A, it will be AA, and B on B, it will be BB. So A on A, if I am considering it as a part of W, I will stay in the same state. Else I have to define this also, like A on A, it will be epsilon, B on B, it will be epsilon, like a popping operation. So this state is for like if it's not a part of the W but the separation. So we will be coming to Q1. Here the same letters are getting popped here, A epsilon, BB epsilon. After this is done, if you encounter no more inputs, top of the stack is Z0, and you'll keep Z0 here as stack content, and you'll reach the final state here. Okay, so what if the string is empty? You'll just reach the final state directly. So you'll have epsilon comma Z0 and Z0. So this is the transition diagram for the given question, which is even palindrome. Okay, so moving on, we have the next question. The number of A's are equal to number of B's. Okay, so how to solve this question? L is equal to, this is the fifth one, number of A's in W is equal to number of B's in W. So how do we approach this question is, first let's understand what the question is, and what is our means technique to solve this one. Number of A's is equal to number of B's. Suppose that W is equal to AB, ABB, A. Is this a valid string or not? Is the number of A's here equal to number of B's? Yes, it's equal. AB, ABB, A, 3 A's and 3 B's. Now in the question what we'll be going to do is we'll be making a stack here. Whenever I encounter A, I'll be storing it, and whenever I encounter a B on top of A, I'll cut it. Then again A, I'll store it. I got a B, I'll cut it. Again B, I don't have any more symbols here, so I'll store B. If I get A, I'll pop it. If I get a B on top of B, I'll store B another time, and whenever I get A on top of B or B on top of A, I'll keep on cutting. Okay, so that's the approach. Let's see how to write the transition function. In the transition function, the first one is q naught comma epsilon comma z naught is equal to q naught comma z naught. After I've written this one, I can encounter either A or B in the first state. So I'll define two states here, A comma z naught, that will be q naught comma a z naught. If the first letter is B, at that time we'll have q naught comma b comma z naught, that is equal to q naught comma b z naught. Okay, these two states I have defined, a z naught and b z naught. Now what if I encounter A on top of A? If I encounter A on top of A, I will remain in the same state, and that stack content will be A, because A cannot cancel A can cancel B and B can cancel A. Same thing goes for B also here. If it's B on B, I'll be just writing q naught on B and B. Now q naught comma A on B as well as q naught comma B on A. At that time it will cancel, so it's the function is simple. You will stay in the same state and cancel, because it's not needed that I should go to another state. In same state only I can do the transitions. Okay, q naught comma epsilon. After I've popped the means A's and B's, if my string is over, two conditions are there. If my string is over, I'm in state q naught, my string is over and top of stack is z naught, that means the stack content is over, input is also over, that means the string is valid. Number of A's are equal to number of B's. If they were not equal, it would have not been z naught, top of the stack will be something else, right? So this check we'll make here, and after that we'll have q naught comma z naught here. Okay, so it's not q naught comma z naught, it's the final state, so it will be like q1 comma z naught. Okay, and let's make the transition diagram. In transition diagram, start from q naught, you can either encounter A or B. So A comma z naught is a z naught, B comma z naught is b z naught, and A on top of A, B on top of B, B, and what if you pop it? Okay, pop operation means A on top of B epsilon, B on top of A epsilon. So when will the state change? When it's 0, means no input is there, top of stack is z naught, and the stack content is z naught. It is the final state here. Okay, so this was about number of A's in W is equal to number of B's in W. The next one is balanced parenthesis. Okay, so let's write the sixth question here. L is equal to balanced parenthesis. Okay, so what does balanced parenthesis mean? So is this a balanced parenthesis? Yes, it is. What about this one? Yeah, this is also balanced parenthesis. And this one? No, it's not. This one? Yeah, it is. So how will we know if it's balanced or not? Okay, that's what we are checking here. How we'll approach this question is, if you encounter this one, you'll means store it. If you encounter this one, we'll pop it. Okay, just like A and B. Okay, so the transition function will be like this. So what is our first transition function? As always, it will be like q naught comma epsilon comma z naught, that is equal to q naught comma z naught. Okay, the next one is q naught comma, I'm encountering the opening parenthesis and it's z naught, so it will be q naught comma opening parenthesis and with z naught, that's the stack input. And the third one is q naught comma, and this one on this one same parenthesis. Okay, so it will be q naught comma same content here. So that is for the opening string. What about the closing string? Closing string cannot appear in the first place, so it will never be balanced, right, if it appears in the first place. So we have to avoid that one. So it can just appear when it's means there is a opening parenthesis here. At that time what it will do, if I encounter this one on top of this one, I'll remain in the same state, I'll cut that. Okay, means pop it. So the other possibility exists of q naught comma this one with this one. If that's the case, what you have to do is q naught comma like this. Okay, so it will get stored here, and actually we need not write this one, because if it gets stored like this, it will never be popped. So we can avoid this one, that's not the right one. And what if it's like this, delta q naught comma opening braces, then we encounter the top of the stack is closing braces. At that time input stack will be like this. Okay, so at that time what we are supposed to do, this also not possible, because this cannot close, means if this close here before that and there is nothing here, this is the unbalanced one, it can never be balanced, because this will never cut off, right. So this also not possible state. So let's avoid that one. So I think these are the only states here. If it is this on top of this, it will be joining, else if it's this on top of this one, it will be popping it. So that's all. If we get the means the inputs are over, like it will be q naught comma input is over, it's epsilon, and the top of the stack is z naught, that means it's a valid balanced parenthesis. So what we'll have here is q naught comma, and here we'll have z naught. Okay, sorry, not q naught, it will be q1. Okay, so let's make the transition diagram here. In the transition diagram, start from q naught, and what you will have here is, when you encounter opening braces and the top of the stack is z naught, what you will have is opening braces and z naught. If it's the opening braces and on the top of the stack also opening braces, you will have two opening braces here. What if it's like your input is the closing braces and top of the stack was opening braces? At that time you will just pop it, so you will reach the, there is no need to reach the another state, right? You can do that here itself. You are encountering a closing braces on top of opening braces, and that's the epsilon. Okay, so yeah, that's pretty much it about these three states. And when it will change is when I get no input and my top of stack is z naught, and this is the stack content, that will reach the final state. So this is a transition so this is the transition diagram for the given question. Okay, the next question is L is equal to a power n and b power m c power m plus n. Okay, and n is greater than or equal to 0, m is greater than or equal to 0. Okay, so in this question what you have to do, whenever I get a or b, store it, and for c, pop both a and b. Okay, so what we'll be doing here is we'll be storing a and b, right? So transition function will be as follows. The first transition is delta q naught on epsilon, it will be z naught, so it will be q naught comma z naught, and from here you are encountering first n number of a's, so you'll have q naught comma a and z naught, you'll have q naught comma a z naught. After that you'll have in the third state, if it's on the top of a, it will be q naught comma aa. And what if it's b? At that time what you have to do, you have to still store it. Okay, you reach another state here from q naught to q1, so on top of means you are encountering b on top of a. At that time it will change the state, but it will store the ba here. After that you have to like do the same for the bb in the q1 state. If it's bb, it will be q1 comma bb. Then the thing happens that you are changing it, means changing it means you will be traversing from q1 to, what is the input you are getting, c, and the top of stack is b. At that time we will pop it. Okay, So let's move to another state q2 and we'll be popping it. Same thing goes for q2 comma c. If you're getting c on top of b, at that time you will do the same thing, q2 comma epsilon. After that, when you encounter another a, at that time what we have to do, 7 means the eighth transition function, q2 comma c on a. If you got c and the input is a here, what you'll do, q2 comma epsilon, you will just cut it. Okay, means cut all the a's here. This will repeat until all the letters are over. At that time, if the letters are over, means what, we are in which state, q2. You're getting the no input, so epsilon, and z naught is the top of the stack. Okay, so you'll have the final state here, q3 comma z naught. Okay, so this is the transition functions for the given question, and let's make the transition diagram. Transition diagram start from q naught. Whenever you get the input a, store it a z naught. If you get the input b, means not here, you'll get a on top of a, then store it a. Then if you get b here, b on top of yeah, it can be z naught, so that's not an issue here. So you'll get b z naught, and if it is b on top of a, that time you will store ba. Okay, so these two are the possible states here. In q1 what you'll have, it will be b on top of b, yeah, b on top of b, and you'll have here bb. So it will keep on continuing until all the states are over, means all the letters in the string which has b is over. And after that you'll have the next one, c. You're encountering c on top of b, then at that time you will be doing the epsilon, and you'll reach the q2 state here. The same thing will repeat here, c comma b, it is epsilon. And when that's over, means how will we know that if that is over, you are encountering c on top of a, c comma a. If this is the case, at that time you'll do the same thing, epsilon. And in this state q3, in q3 state, if you can make the changes here itself, right? So q naught, from q naught it was a, and b on a I changed to q1. So in the q1 I'll be encountering the number of b's. If that is over, I'll change to q2. In q2 cb is there, and q2 only I have defined ca also, right? So yeah, that I can do. So I'll be writing here ca as well. If you want, you can change also, ca will be here, and this is the state for when the input is over. So input is over here, and the top of the stack is z naught, and the stack content is z naught. In that case also you will reach the final state here. Okay, so this is the transition diagram. Coming to the eighth question, the question is that we have to accept those strings in which the number of a's are greater than number of b's. Okay, so one of the example can be a b a. Here the number of a's are greater than number of b's. Only these strings they should accept. Okay, the transition diagram. So we'll be starting from here in the transition function. Before that, let me give you the overview. So the overview is that when we accept all the strings, means if they input the process all the string, at that time we'll accept a here. If it's b after a, we'll cut a. If it's a after a, we'll keep that. Okay, and when we end the input string, if the input is epsilon, means the string is ended. At that time I still have a on the top of the stack. That means its number of a's are more than number of b's. Okay, so that's what my indication is, and by using that I'll be solving this question. Okay, so this is the transition function. First one, q naught comma epsilon z naught, that is q naught on z naught, and q naught, if it is a on z naught, it will be a z naught. If it's b on z naught, it will be b z naught. If it's a on a, then insert a on a. If it's b on b, insert b on b. If it's like the reverse, like a on b and b on a, then it should cancel both. Okay, so it will be epsilon, and what will be remaining with is, if the input is epsilon, means the string is over, but still I have on the top of the stack a. At that time I will move to a different state q1, and I'll do the pop operation. I have to clear all a's, so the input is epsilon, and if that means top of stack is a, at that time I will erase it. Okay, so it will be q1 comma epsilon. And the last one means if the string is if the top of the stack is z naught, that means my string is over, means the stack content is over and z naught is remaining. I'll move to the final state q2. Same thing I have done in the diagram as well. So I have how many states? 3 states here, q0, q1 and q2, and in Q naught I have like AZ naught, AZ naught, BZ naught, BZ naught, AA, BB, BB. If A on B or B on A, it will be epsilon. Okay, and if it's epsilon on A, it will be pop operation. So means the number of A's are more. So I have to clear all A's in the stack. After clearing that, the final state will go to, means that this is the final transition, it will go to Q2. Okay. Moving on to the next one, ninth question is about a power m, b power n, where m is not equal to n. So how can you make sure if m is not equal to n? M is not equal to n means m is greater than n or m is less than n. Okay, so we'll have two cases here, m is greater than n and m is less than n. This is the same thing here, a on z naught, a z naught, a on a. If it's b on a or a on b, at that time it will be like see, it's not in the our wish order. It is firstly A's will come and then B's will come. So firstly we should have A's. So I have A's here, A on A. If it's B on A, I'll move to the new state and epsilon. In new state I'll cut all the A's from the by using B's, and after that if A is remaining, at that time I'll move to the new state. See, after cutting all the what I mean is, suppose that the string was AB A B A. Okay, in this case first A was cut by this one, this string can't be possible, right? A B B. Suppose that this is the string here, A, and from the first B this got cut and second B this got cut. Now my input is over, so I have taken here epsilon, and my still of the top of the stack is A. That means A is more. There, in that case I will move to Q2. If A is more, I will move to which state? Q2. Okay, and in case B is more, I am still in Q1. If B is more means it will move to Q4. Okay, if A is more, it will move to which one? Q2. If B is more, it will move to which one? Q4. Okay, now this shows that either A is more or B is more. Two states are here, Q2 and Q4. Okay, and what will be the case when B is more? How will be that possible? Like for example, if I have B will be more when m is equal to 2 and n is equal to 4. In that case, what will happen? If I have like A, then 4 B's are there in the string after A. At that case, BB will cut this one, and I have the input as B, but my top of the stack is Z naught. So I have to make a change here. The input is B. Okay, in Q1 my input is B. Here the change is there. Input is B, and the top of the stack is Z naught. If this is the case, then I will go to Q4, and I will not do epsilon because means B is here. I will not do anything. It will be just Z naught itself. Okay, so there is a change here, and after reaching this state, that means number of B's are more. So what I have to do is I have to just ignore all the B's. So I will be writing the same function with Q4. So I will have Q4 here, B Z naught, and that is equal to this one, Q4 comma Z naught. I will ignore all B's, and after all the B's are over, this will have epsilon here, epsilon comma Z naught. Okay, epsilon comma Z naught, it will reach the final state Q3. Now in the first case it was A, right? Epsilon on A, Q2 on E, and I will cut all the A's from the stack and move to the final state. Means this is the cutting of the A's. After that the string is over, I will reach to the final state Q3. Okay, if it's for the B, I have just told you what to do. I just ignore all the B's, and after ignoring all the B's, reach the final state. Okay, when input is over and the top of the stack is Z naught. So this was about the 9th question. This is the transition diagram here. Slight changes there, which I told you make the change accordingly. So what will be the change happening is, this will be same A on A on Z naught it is AZ naught, B on A it is epsilon, and B on A it is means it is getting cut. And here the change what you have to make is, it's not epsilon comma B, it is B comma Z naught. At that case you have to just keep it as such, Z naught. This is the change which you have to make here, and the same thing you will write here also, and this is the same thing here. Okay, just here and here make the changes also in the transition function, and the above part is same. Ignore all the A's here. After you get means pop all the A's which are in the stack. After that gets over, you will move to the final state. This is epsilon comma Z naught, it will move to the final state Q3. Moving on to the next one, we have A power m, B power n, A power n, B power m. So here what we'll be doing is A power m and B power n. So this is the stack. Suppose m is equal to 2, n is equal to 3. Suppose that this is the case. Okay, so what I will be doing is A power m, right? A power 2. So 2 A's will come here. After that n is equal to 3 means 3B should come. I'll accept it. B B, B. After I have done that, I will change the state, this for Q0 state and this for Q1 state. After that is done, my next thing is A power n, B power m. A power n means A cube. A cube will cut these 3 B's. B power m means B square, 2 B's. 2 B's will cut this one. If I reach the final state after means getting to these states, I'll be means I have reached the final state and the string is valid. That will be the conclusion. So these are the functions which I have written here. Let me summarize it for you. If AZ0, A. If it is BS, still accept it. B on B also accept, and change the state from Q0 to Q1 when the B start coming, and A on B cut that, and how many ever on A's and B's it's there, cut all those, means this is getting cut here, A power B power n on A power n, and after that gets cut here, then B on A. Okay, see, after this gets cut here, what happens is the B's will be remaining here, and the input is means the stack has A's, so B on A it is getting cut. So that's what I have written here, B on A it is getting cut here. We will be moving to new state Q3. They will cut all the B's on A's, all the A's by using B's, and after you means the input string is over and the top of the stack is Z0. That means the string has been over and it's a valid string. It will means the transition will be going to final state. Okay, seeing the transition diagram, that's also simple here. First accept all the A's. If it's B on A, change the state, accept all the B's, then cut the B's using A's, then cut the A's using B's. Okay, after that gets over, move to the final state. This is the last one, which is A power n, B power m, and A power n. Here what we'll do is A power n is there, right? First we'll have Z0 here, we'll accept all A's here, A. After that, whenever you get B power m, just ignore it. Okay, means B power m is there, don't do anything, just ignore all the B's. Then after that, A power n is there, cut all the A's using the this A. Okay, so the transition function will be as follows: AZ0, A, B on A, just ignore it. How you'll ignore is that B on A, when it comes, don't insert B, don't pop also. So what is on top of stack? A, that will remain A itself. B on B also, top of stack is A, it will remain A itself. After that, when B's get over, if it's like the input is A and the top of stack is A, since you are not inserted any B in the previous iteration, so we'll have A on the top of the stack and the input is A, so we'll cut that. So which is that A? These A's are in the stack, these A's are now the input. Okay, so we'll be using these A's to cut these A's. If they are equal number, at last we'll reach after cutting A's, we'll reach epsilon, and the top of the stack will be Z0. What I mean is, this is Z0 here. If I have 3 A's here, at that time A power n is also like in the last we have another A set, right? So if the number is equal, at that time string will be over epsilon and the top of the stack will be Z0. If both things are satisfied, my string is valid and I'll reach the final state. Seeing the transition diagram, accept all A's. If it's B, just ignore B's by using this one. Here it's B comma A. Okay, make the change, and after that gets over, if you get A on A, epsilon means pop it, pop until you cut all the A's. If you reach the finals, if you clear the stack and the top of the stack is Z0, and at the same time if the input is also over, that means the string is valid, equal number of A's are there in the starting and in the ending, so we'll reach the final state. Okay, this is the last topic in module 3. Here we have 3 methods: normal method, top down method, and bottom up approach. Okay, so we'll be solving each under each method we'll be solving few questions. Okay, so this is the question given to us. We have to convert the question into PDA. So in the normal method, first you have to see how many letters are there: S, A, B, C. For each of these letters you have to do the following. For S you have to write, then what you have to write is, just remember the sequence. When you're starting, you have to write Q, Q0, epsilon, epsilon, then Q1, it goes to Q1 and S here. That's the first step, okay, in normal method. After that, after you have done that, you see where is S going to. S is going to small a, then capital A, B, B, small a, capital A. So for the same letter A and A here, it's going to two different things. So what you will write is Q1 on A from S, it's going to this one as well as this one. So here also it's same, AS, it's going to this one and this one. Collect the non-terminals, which is AA, put it in the LHS part and write the means this is the terminal, sorry, collect the terminals, write in the LHS part and write the non-terminals in the RHS part. Considering the second one for A, which is the non-terminal here, A here, which is the non-terminal. So two possibilities are there, A with BB and A with epsilon. Okay, so A, what you will write is collect the terminal here. So it will have Q1 comma A comma from where you are going A, and from to where you are going Q1 comma BB. Same thing you will write here also, just the difference is here it will be epsilon. For the B also it's same, here we have two non-terminals, B two terminals, small b and small a. So you will have Q1 comma small b as well as small a here, from where you are coming, from B you are coming, and where you are going to Q1 comma where you are going BB and epsilon. So for the first one, which is for small b, you will have capital B, and for the this one you will have epsilon here. C goes to A, that's the same thing here, Q1 comma it goes to A here on C, then it goes to Q1 comma, since it has no non-terminal here, it will be epsilon here. So these are the rules which you have to write for the given question. Okay, so this is by normal method. If they don't specify anything, that's the normal method. If they specify like top to down or bottom up approach, at that time you have to do the specific approach which they have asked. Okay, coming to the second one, here we have AZ, it means this is the answer. Okay, in the question you have been given with the functions, right? So let me open the questions first. See, this is the question given to us. This is the terminal from where you are coming, Z. So first write here Z. Okay, and this terminal you have A, what it is giving, AZ. So this is the first string. Next the non-terminal is A, from where you are coming, capital A. Capital A goes to small a, along with that capital A is there. Also it goes to small b, and capital means epsilon is there. So you will have these two things, and final state is this one. So these are the two states which you have to write. Okay, coming to the next one, here also you will do the same thing, collect the terminal and write it here, and after that what you are getting ABC you write here. Same thing goes for A and B as well. Okay, and finally you have to write the final state, epsilon epsilon, it goes to Q2 comma epsilon. Coming to the fourth one, here we have 0A, and the same thing, what is the terminals here, 0 and 1 terminal. So you will have for 0 and 1 it's coming from S, and where it's going A and B. Okay, same thing goes for here also, you will do the same thing. So this was for the normal method. Coming to the top down approach, you have to write three steps here. Step 1, Q0 comma epsilon, Q1 comma S. This is the default step in all the CFG to PDF methods. Okay, so after that you have to write the step 2. In step 2 what you will write, you are starting from Q1, so write all the places Q1 here. Next state, all the places epsilon here. After that, how many states are there, S, A and B. So for S you are going to A, B, from A you are going to A, B you are going to B. Just remember these steps. Next, what is the terminals? The terminals here are small a and small b. So what you will write here, Q1 you will write as usual, then small a small b, it goes to epsilon epsilon. Similarly we have this one, here how many states are there, E, T and F. Okay, so step 1 is this one as default. Step 2 you will write Q1 here, then you will write epsilon, then the first state is E. For that two transition are there, so I have written 2 times. First one is E plus T, second is T, E plus T and T. After that again we will write the same thing for T as well as F, what all we are going, that we will write. After that write what is the terminals. Here terminals are how much, how many terminals are there, plus, and this is actually star. Here we have opening bracket, closing bracket and ID. These are all terminals. So for that we will write the terminals here 2 times. Q1 you write here, then the terminals, same terminals right here, then epsilon here. That is a top down approach. Here also it's the same thing, how many terminals are there right here at the end. Before that write from S where all you can go, write those things. Okay, coming to the bottom up approach, here the first thing you have to write is B, P. Okay, you will write here P, which are the terminals, A and B, right? So A and B, then epsilon, the reverse of previous one, P comma A. In the step 2 also, which are the states you are going to, the state which I am going to is epsilon, AS, BS and AS. So 3 times you will write here AS, BS and epsilon, from which you are coming S. If there is some more also, you will write those things here, and from where you are coming you will write in the place of here. Like here what you will write, as you have written S, from where those next set of symbols are coming, you will write those that letter's name here. Okay, and finally you will write this one, P epsilon and S, it goes to QF comma epsilon. Okay, that's the final step. Discussing another one question in the similar way, what we have is first you will write P's, the terminals will be written first and epsilons here, and as the previous one we have written epsilon only here, so the same symbol you will write here, P comma that symbol name. Okay, I've written for the terminals, then for the non terminals P epsilon the non-determinable answers you will write, and from where you are coming, that you will write, from which letter you are coming. Okay, then finally you will write this one. Okay, coming to module 4 and module 5, the module 5 is the theoretical topics. Any of these questions would be asked, so all are equally important, so go through that. It's very simple, just remember the key points. Okay, and coming to module 4, there are two things here: the Turing machine questions. There are few questions which are like standard questions. From that, the questions are asked in exams, so solve all those questions. Refer to my module 4 video of Automata. Okay, and for the theory questions, I have discussed some in the means that video, module 4 video, and some theorems are left, which are 3 theorems that I will be discussing now. Okay, so the first theorem is that every language accepted by a multi-tape Turing machine is by some single tape TM is acceptable by some single tape TM. Okay, so whatever multi-tape accepts, it's acceptable by single tape TM. So that we have to prove. So for the proof, you will start like this. Suppose that there is a language L accepted by a K tape Turing machine. Means multi-tape means what? There are multiple tapes. So we are assuming 2 K tapes are there. Okay, and we simulate the single tape with 2K trails. Okay, so for K tape, we will assume a single tape with 2K trails. Now what we have is the even number of trails will have the content of the K tapes. Okay, content will be stored in the even numbers, and the header will be stored in the odd numbers. So if I give you a visual representation, this will be the thing. First you have to make the finite control, then make the grid here. In that grid you can find out two things. This is the first tape, this is the second tape. So this is the first row, this is the third row. In the first and third row you can find out the x. Okay, x is nothing but the header, currently where it is pointing to, that is stored, and this is the string value which the multi-tape has, that will be stored here. Okay, in that way you have to make the Turing machine, and after that this is just the explanation of what I have just told you now. And in each move, what will happen is m will move each time. M is the machine, it will move each time for all the strings here, and it will get the knowledge of all the updated values. Based on that, it will change the iteration, means which state it has to go, and after that is done, change is done, it will move the header to the next state. So this is the just the point you have to remember here, and explain the working also. So what all you have to do? First you have to write down the description of it, how many tapes are there, in which tape what is stored. After that, make this diagram and explain the working of it. Okay, means how the moves happen and what changes. That's all what you have to do in the first theorem. Second theorem is about single tape Turing machine simulating multi-tape Turing machine. The time taken is O of n square. Okay, this if you get, I give you a visual representation, what will happen is, suppose that this is the single tape Turing machine, from here to here it is there. Okay, so for making a change here, what will happen is, suppose that here were A1, A2, A3, A4, A5. Okay, so for B1 I will go to A1. How many states I have traveled? I have traveled n states here. Okay, then from B2 to A2 I am traveling again n states. So n plus n, again n plus n, n plus n, n plus n. So n times I am traveling n. So what will that be equal to? N square. Okay, so that the time taken will be n square. That's what you have to describe in the theory also. There is a K tape Turing machine, and n moves it is there. Okay, means for the first tape it will be n moves. For making any change, it should travel 2n moves. Okay, and for turning also it will be making. See, this is the same thing. Where it starts from, to simulate any change, it will move left by 2n cells and all. And after that, to make a change, it will use 2k time. 2k time it will use to reverse. Okay, means once it has gone here, it will take 2k moves to come back. So 2k plus 2n into 2. 2n is for traveling this side, again 2n for this side. So 4n plus 2k. And how many times I am doing this one? I am doing n times. So n into 4n plus 2k will give me n square, means big O of n square. That is the time complexity. That's all for this. That's all for the second theorem. And the third theorem is about non-deterministic Turing machine. In non-deterministic Turing machine, what will happen is, for one transition like Q0 on A, we can go to multiple states like Q1 on B, Q1 on C, Q2 on C, and so on. So for one transition we are going to multiple states. These all states are stored in ID. Okay, the different states are stored in ID. So what you will say is, you construct a Turing machine, multi-tape Turing machine, and it has ID also, and it will reach the final state after traversing all the states. Okay, so it will start from ID, and star is used to store the where it is currently pointing to. I mean, star is the separator, and X will store where it is currently pointing to. See, this is the diagram. By this diagram only you can understand what I am trying to say. these IDs are the different Turing machines, TM1, TM2 till TMn. Okay, and this is the separator, star are the separators. In the first part of the answer you have to describe these things. Finite control takes care of all of these IDs, and x is where the current pointer is pointing. Okay, what will happen is, for this transition, if it goes to k states, okay, k states it goes to, it will create k tapes. After it creates k tapes, wherever each tape has to go to, it will make that corresponding change. After the change is made, it will move to the next ID. Okay, so that's what I have written here, the working of it. Once it has scanned any symbol, it will have k triples, it will make k copies of it, modify the k copies, and after that return to the current ID, and when the change is made, it will move back to the step 1. Okay, so this is all the theorem about, and the remaining topics of module 4 like the Turing machine questions, refer to my video, and the fifth one, the notes are sufficient. So yeah, that's all for this video, and thank you so much for watching. I'll see you in the next one.